Learn how to use Selenium with Java using Page Object Model, and master the art of automated web testing. Selenium is a powerful tool for automating web browsers, enabling you to simulate user interactions and verify web application functionality. This course will guide you through setting up your first Selenium test in Java, implementing the Page Object Model for cleaner and more maintainable code, working with various web elements, and more. By the end, you'll be able to create robust, efficient, automated tests for any web application. Rex Jones II created this course. Rex is a popular online instructor and excellent developer.
Hello and welcome to Selenium with Java using a Page Object Model. My name is Rex Jones II. I am from Dallas, Texas, and will be your instructor. The course level is for beginners, but it will progress up to an advanced level. I designed this course for anyone who wants to learn Selenium test automation. So if you're a beginner, do not worry. You and your team should watch this course if you want to quickly execute your test scenarios in your web application before deploying the software application to your customers. My strategy is to thoroughly explain what, how, and why, what I am going to do, how I am going to do it, and why I am going to do it. The concepts will be demonstrated step by step. They are the same concepts that I implement on my job projects to catch regression bugs in the application before our customers catch those same defects in production. You and your team will have a solid foundation of how to automate scenarios using Selenium. To become very effective with automation, I recommend learning a programming language like Java. With programming, you will understand more about automation. freeCodeCamp has some beginner courses that will help with Java. The basic programming principles are enough for test automation. This first course has over 1 million views, and this second course has over 3 million views. In this Selenium course, I will share some tips and shortcuts from my 15 plus years of experience. Those tips include how to write good code like a professional engineer. My experience consists of being an author, consultant, and trainer. You can follow me on YouTube, LinkedIn, Facebook, Twitter, aka X, and GitHub. All of the source code from this course is placed on GitHub. You can go to my website at rexjones2.com if you want to see more about my books, blogs, and other videos. When it comes to Selenium, it is a family of 3 components. WebDriver is first. And when people refer to Selenium, they normally are talking about Selenium WebDriver. Next is Selenium IDE and Selenium Grid. Selenium WebDriver is an API that allows a user to automate a browser. Selenium IDE is the record and playback tool. Selenium Grid executes our WebDriver test scripts on more than one real machine or virtual machine in parallel. We are going to use Selenium WebDriver. The architecture for Selenium WebDriver consists of a client-server model. The client makes a request, and the server executes that request. The client consists of Selenium clients and WebDriver language bindings. The server consists of browser drivers and web browsers. Selenium client is responsible for sending out a request to perform a command. The WebDriver language bindings is a code library designed to drive actions on a web browser. Each language has its own bindings. Therefore, the same commands written for Java is also written for C#, Python, Ruby, and JavaScript. The browser drivers first receives a request, then it returns a response. Notice there are two directional arrows between the browser drivers and web browsers. You will notice in this tutorial that Selenium executes our test scripts very fast. The browser drivers receive a request and immediately the web browsers execute that request. In this course, Java will be the programming language and the test framework will be TestNG, which is short for Test Next Generation. Last is the Page Object Model design pattern. The Page Object Model design pattern considers each web application page as a class file. Here's some of the benefits of Selenium automation. It's open source, so we can use Selenium for free. Good to implement with CI/CD. Selenium is supported by multiple browsers and operating systems. Selenium helps with regression testing. With the click of a button, we can catch a defect before the application is released to production. This diagram shows an interconnection between application features. The gray boxes 1 through 5 represent existing features, and blue boxes 6 through 10 represents new features. Someone can start and complete feature number 10. After number 10 goes through the software development lifecycle, then it is determined the feature is ready for deployment. However, number 10 is connected to existing features numbers 4 and 5, plus the new feature number 8. As a result, number 10 can be good as a feature, but features number 5 or 8 can break. Automation can quickly perform regression testing when there is time limitation. When there is a time crunch, sometimes features from a year ago or longer are not tested again. In QA, the plan is for those using automation and those who don't use automation to complement each other so a software is delivered to the market with quality. After this course tutorial, you will see how it is organized into 4 parts, and Selenium can help you when there is a code change in your environment. This tutorial is organized into part 1, which will set up our project and create the first Selenium test. For part 2, we will create a page object model. For part 3, we are going to work with WebElements. For part 4, I will demo Selenium interfaces and methods for unique situations. The description has links to each part. Let's get started with part 1. Welcome to part 1, where we set up the project and create our first Selenium test. In this part, we will set up our project by installing Java and downloading IntelliJ. The builder tool will be Maven, which helps manage our project by adding dependencies to the pom.xml file. Selenium and TestNG are the only dependencies we will use for this project. Selenium automates the steps in our application, while TestNG is the framework for verifying the steps in our application. Next, we will transition to creating our first Selenium test with Java and TestNG. Let's set up our project. In the browser, we will search for JDK, and I am using Firefox as the browser, but the browser you use really does not matter. JDK is short for Java Development Kit. The purpose of JDK is to help us develop our project using Java. It has code for us to reuse. It has a compiler, and it has a runtime environment. Click Java Downloads from Oracle. JDK is the latest long-term support release of Java SE platform. SE is short for Standard Edition. Let's select JDK 21, and we see three options. The operating systems are Linux, Mac, and Windows. I have Windows. Now, I will download the installer. Well, I'm not going to install it because I already have Java on my system, but I'm going through the steps so you can know what to install and what you need to do next. When you click Installer, go to your Downloads folder and follow the instructions when you execute the file. Last step is to go to your environment variables and paste in the JDK bin folder path. Next, we need an IDE, which is short for Integrated Development Environment, and it is a place for us to write our code, compile our code, and run our code. Go to your browser and search for IntelliJ if you want to use IntelliJ, but there are other IDEs for you to use for Selenium using Java. Type in IntelliJ, and there it is, IntelliJ Downloads. Now, at this point, we select the option from JetBrains. Scroll down to the Community Edition, then click Download. When you click Download, when you go to your Downloads folder, just follow the instructions and they will be detailed for you to know what to do next. Now, let's create our project in IntelliJ. Open up IntelliJ. The first step we do is click New Project. Select Maven. The name will be, how about Selenium Free Code Camp. Then click the Create button. Now, we're getting ready to go to the pom.xml file. So at this point, we are going to organize Selenium 4 and TestNG. In this pom.xml file, we see the artifact ID has Selenium Free Code Camp. We have the property tag, and the property tags compiles our code using Java. The next step is to add our dependencies. A dependency is an outside library that our project requires to compile, build, test, and run. Let's start with these dependencies, and now we need to add our dependencies. Go back to the browser and type in MVN repository. That's where we can get our dependencies. Select it and search for Selenium 4. There are many options, but the option we will use is Selenium Java. Make it a little bigger, and we see the description shows Selenium provides support for the automation of web browsers. The ranking shows that Selenium is #1 for web testing. At the time of this recording, the most recent version is 4.23. And it came out July 19th, 2024. The next step is to click in this area and copy the dependency to the clipboard. And also you can uncheck this here checkbox for include comment with link to declaration. Either way is okay. Go back to IntelliJ and paste. We have added the first dependency. The second dependency is testng. There's another way to add dependencies. That's if you know the dependency that you need. I'm going to show you first by making room in this pom.xml file and add the tag for dependency. Control space if you have Windows. And we see that the options show up. I will select testng. Then select org.testng for the group ID. For the version, I will select the most recent version, which is 7.10.2. Bingo. Now, that's it for setting up our project with Java, IntelliJ, Maven, Selenium, and the testng. Now, let's create our first test with Selenium using Java and the testng. The first test will log into Orange HRM by entering a username and password. Admin is a username. Admin123 is the password. The difference is admin with username has a capital A. Admin for password has a lowercase a. Let's go back to IntelliJ and create our test. And if you are here and you added your dependencies, make sure to load the Maven changes. For the test, we expand the test directory. Then right-click Java, New Package to create our Part 1 package. Right-click Part 1, New Java class to name our first Selenium test. Now, let's write our code. Starting with WebDriver. Hover WebDriver and it says import class. It's not a class, but WebDriver is an interface. Import, and we have driver. Driver is the object reference. The purpose of WebDriver is to control the browser and help find elements. Next, we have a testng annotation called before class. Before class is a way for us to run this code before the class. The code we want to run is the setup code. And we begin the method by writing public void setup. Create an instance of Chrome driver by writing driver equals new Chrome driver. Then we maximize the window with driver.manage.window.maximize. Next, we load AUT by writing driver.get. Get loads the new web page. So let's go back to the AUT and get the URL. Then paste the URL. Now we are finished with the setup method. The next testng annotation is after class. After class helps clean up our test, and it operates like a post condition. Let's close the browser by writing public void teardown. We can also close the browser two ways, driver.quit and driver.close. The difference between quit and close is quit closes every window and quits the driver. Close only closes the current window. The standard for Selenium is to use driver.quit. At this point, let's create our test using the test annotation. The test annotation identifies our test method. Public void. The name is test login into application. Now, when it comes to automation, there are two key steps. The first step is to find the web element, and the second step is to perform an action on the web element. We find an element by writing driver.findElement. Next, we write how we want to find the element by dot. By is a class that is used to locate elements. We find the element by a Selenium locator. There are 8 locators we can use in Selenium. It provides them so we can find the element. Now, in alphabetical order, we have by class name. We see there are 2 options, but we need to use by dot class name and not by class name. It's the same for the next locator, which is by CSS selector. We use by dot CSS selector. Next is by ID. We use by dot ID. After ID is by link text. Then we have by name. By dot partial link text. After partial link text, we have by tag name, followed by the last locator, and it's by dot XPath. Let's find our first element by going back to the AUT. We inspect username by right-clicking username, then select inspect. Let me make this bigger so you can see it better. This username element has one tag, which is input, and it has 3 attributes. Input, tag name, attribute class, that's 1, attribute name, that's 2, placeholder, that's 3 attributes. I prefer the ID attribute, but it's not available. Most of the times, the ID attribute has a unique value. Sometimes the name attribute has unique value. So let's use name. And the value for name is username. Let's inspect password. And it does not have an ID attribute, but it does have name as the attribute. And the value is password. Let me go back to the IDE, because now we're going to write our code to find the element and perform an action on the element. Driver.findElement by name. Double quotes. Now we add the value, and the value for username was username. Okay, now within the double quotes, we add the value for name. At this point, we need to assign it to an element, which is WebElement with an object reference of just name and username. We need to import WebElement. When I make this L lowercase, it also has import class, but WebElement is an interface that represents the HTML element. This statement is saying we want to find the element by the Selenium locator name. The name attribute has a value of user name. We are finished with the first step of finding the element. The second step is to perform an action on the element. We write the object reference, username, dot, and the IntelliSense has a lot of methods that we can use to perform an action. However, send keys is the method we need because it sends information to the element. Admin is what we send for the username. Our test script would type admin into the username field. There are 3 ways to find an element. The second way is to write var with an object reference of password equals driver.findElement by name, and the value was password. Var is a Java keyword that infers the data type based on driver.findElement. Now we found the element. The second step is to perform an action on the element by writing password dot, and we want to send the keys. The keys we send is admin123 with the lowercase a. Last step is to click the login button. Therefore, we go back to the AUT, inspect login, and it has a button tag name, but does not contain an ID attribute. A quick way to find this element in the DOM is by the tag name. In this search HTML bar, we can write 2 forward slashes, button, then press enter. This web page only has 1 button, and it is identified as a unique element because we see 1 of 1. Plus, this element in the DOM is highlighted, which means we found the element. Now, all we need to do is go back to IntelliJ, and for our Selenium test script, the third way of finding an element is by writing driver.findElement. And notice, the third way does not have an object reference like the first 2 ways. The object reference was username and it was password. For here, we do not have an object reference. We write driver.findElement by tag name, and the tag name was button because in the DOM the tag name was button. Okay, so that's how we found the element. First step. Second step, perform an action, and for buttons we click. That's it. We are finished with our first test when it comes to automating the first test. Let me add a sleep statement before entering the username. Thread.sleep, then pass in 2000. 2000 milliseconds is the same as 2 seconds. And I'm going to add a exception, throws interrupted exception. Now, let's run. It executed so fast that I did not see what happened after logging into the application. Therefore, let me comment out driver.quit so the browser does not close. And we're going to run again. And this time, we should see the test script log into the application. Bingo, we see what happened after clicking the login button. We have automated the test steps, but now we have to verify the test script. Test ng will be used to verify the test with an assertion. Therefore, in the IDE, let me write assert dot, and there are many overloaded methods that we can use to verify if our test passed or if our test failed. Okay, so what happens next is going back to the AUT. And this time, rather than using Firefox, because I have not logged into the application, I'm going to use the browser that we just used to automate the application. And we know it was used for automation because it shows Chrome is being controlled by automated test software. Now, when this page loads, what are we going to use on this page to verify that our test script logged into the application? We can inspect anything on this page to verify, but since it is the dashboard page, let's verify dashboard. And I will inspect dashboard and bring this pane to the bottom. Also make it bigger so you can see it much better. Now I'm going to inspect dashboard again. Yes, we see it has an H6 tag name. Do you see dashboard between the H6 starting tag and H6 end tag? Dashboard is text that is shown in the DOM, but also shown in the application. That's what we would use to verify our test. Now, let's find it first. And since it has an H6 tag, I'm going to hit Control F, write 2 forward slashes H6. Yes, and we see it is highlighted yellow or orange. I'm not sure exactly what color you would call it, but it's highlighted. And it shows 1 of 1. That means we found the element by using the tag name. So going back to the IDE, before the assertion line, I'm going to write thread.sleep 2000. It is not recommended to use thread.sleep in our test scripts because it is a hard stop, but I'm using it for demo purposes. Selenium has different ways to waiting for our test script, but thread.sleep is a Java sleep statement. Driver.findElement by tag name, and the tag name was H6. Okay, so Selenium has a method to get text from an application, and it is called getText. After getting the text, the value is returned as a string. So we assign it to string actual result. Now let's write what we expect, which is string expected result equal to dashboard is the value we expect to see after logging into the application. Now we can write the assertion. Assert dot, let's use assert equals. With this assert equals, we see it shows different overloaded methods. We see char actual, short, int, but the actual result and expected result are strings. And actual result goes first, and we're going to compare it to the expected result. Now our test is complete. Let's run to verify if our test passes. We see the application, the dashboard, and we see the run window has a green check mark, which means a pass. It is a good habit to make your test fail, because if the test passes when it should fail, then we know there is a problem with our test script. For example, let me copy this class, then paste it in part 1, rename it to, how about login should fail test. I will make it fail on purpose by changing assert equals to assert not equals. And let's run again. Let's check the IDE. And yes, we see a yellow X in the run window. It failed. In the console, we see assertion error. Did not expect dashboard, but found dashboard. Now we know that we made it fail on purpose, but in my production code, I would fail the test, then change assertion back to assert equals so it can pass. That's it for our first Selenium test with Java and TestNG. Next, in part 2, I will demonstrate how to create a page object model design pattern. Welcome to part 2, page object model. A page object model is a design pattern that is used as a component in our automation framework. The purpose of a page object model is to serve as a pattern for the application under test, AUT. In this part, I will introduce the page object model and create a page object model. Then create 2 test scripts using the page object model. For the introduction, let's look at the design pattern. In this diagram, we see web pages, page objects, and test scripts. Each web page is represented by a page object. The design pattern has variables and methods inside of a page object class. Variables represent the elements on a page. The methods interact with elements and allow us to represent the behavior of an application. The test scripts are steps that we implement to automate and verify the application. All steps reuse a page object when it needs to interact with a page. One of the main points is to store the variables and methods separately from the test scripts. This separation provides 3 benefits for our code. The benefits are reusability, readability, and maintainability. Code reusability prevents us from rewriting the same code. Code readability is code that's easy to follow. Code maintainability takes less time to make a change to our code. We create a page object class to operate like the web page application. That is why the diagram has web pages and page objects. The home page for web pages is connected to the home page for page objects. It is the same with the help page. The web page is connected to the page object. When it comes to the test scripts, they have access to any page object class. Test script 1 can call the home page object and the help page object. The second test script also has access to call both page object classes. All test classes, including test3, have access to each page object class. A true page object model can follow the concepts of object-oriented programming, encapsulation, inheritance, abstraction, and polymorphism. It is not required to follow the four concepts. However, your design pattern is likely to create a code smell if it does not follow the object-oriented programming concepts. A code smell happens when your code does not follow fundamental standards. Notice three approaches in this diagram. First approach, all arrows are pointed up. From the bottom, we see the test scripts make calls to the page object classes. The arrows are not pointing down because page objects should not call test scripts. In the middle, page object classes contain variables and methods. The variables values are received from the web pages, and the methods emulate actions from the web pages. The second approach is the page object classes do not call other page object classes. So there is no arrow pointing from home page to help page, and vice versa. The third approach, there are no arrows pointing from each test script. That is because test scripts should not call other test scripts. However, the test scripts can call the base test, and the page objects can call the base page. A base page and base test are not required for our page object model. The same way a test script can call a page object, a base test can call a page object and a base page. The base test helps us to not repeat the same code in our test scripts because it has information common to all test scripts. A base test and base page operate like each other by serving as a parent class. A base page has methods common to all page object classes. So here is a complete diagram of the page object we will design in this course. Now, let's create the page object model. The AUT will be saucedemo.com. Swag Labs is the application. It has 6 usernames that are accepted and 1 password for all users. There will be a total of 2 test scripts. One test script enters a username like standard user and a password that is not correct, such as ABC123. Then click the login button. The test verifies this error message shows up. Second test script logs into the application and verifies the next page shows up. I will start with the base page. The base page and page objects are placed in the main directory, while test scripts are placed in the test directory. Create a package by expanding main, right-click in Java, new package. Name is saucedemo.pages. Now we are going to create the page class. And we do that by right-clicking the pages package, new Java class. Name is base page. And the base page for now will be abstract. With inheritance, the base page only has one role, and that role is to be a parent to all page object classes. In Java, the parent class is also known as superclass. The subclass inherits from the superclass. In this course, I will refer to the subclass as the child class. So the relationship would be parent class and child class, but it is the same as superclass and subclass. Since the base page is a parent class, it should contain class members that is necessary in the child classes. The keyword abstract is not required, but it helps to prevent any child class from trying to create an instance. Abstract classes cannot be instantiated. We have the option of creating a constructor in the base page and adding a constructor to each page object class. Another option is to not create a constructor. So in this tutorial, I will not create a constructor. Therefore, I will set the driver in the base page and make a call from the base test. So I need to remove abstract before creating an instance in the base test. If I had to add a constructor, then it would be a good idea to keep abstract. When it comes to the driver, let's make it public, static, WebDriver. Set the driver so all the page object classes can access the browser. Public, void set driver. The parameter is driver, and I'm going to import WebDriver. Base page dot driver will get assigned from the driver we pass in. Let me also make some room so I can scroll up and down the editor. In addition to accessing the browser, all page object classes need to find an element. Recall, find element is the Selenium method we use to find an element. So let's write protected WebElement find, pass in by locator as the parameter, and it will return driver.findElement locator. Import WebElement and the by class. Now, when it comes to the access modifier, we have it as protected because we only want to reuse this method in our base page and all of our page object classes. WebElement is the return type because findElement returns WebElement. Most likely, page object classes will click an element and set data into an element. So let's write protected void set, pass in by locator. The text will be string. We pass in string. For the data, our test script will set into an element. The by locator is a parameter for locating an element. Watch how the find method reduces code duplication and increases code readability. Rather than writing driver.findElement and passing in locator each time, over and over in the page object model, we only can call find. When I call the find method that we created in the base page, look how much it is better for reading. Find that we call is returning driver.findElement. Therefore, I do not have to write driver.findElement again. So let me remove driver.find element and only include find. Find locator. And that's it. Now I'm going to clear. If there is data in the element, then clear the data and write find locator dot send keys. Then pass in the text that is sent to the set method. The return type is void because send keys returns void. There is no data returned when we send keys. Now, the next method is protected. Void click. We pass in by locator. We're going to find the locator, then click the element. The same click method will click a button, it will click a link, it will also click any other element on a web page. That's it for the base page. Next is the login page. Let's go back to the login page. Our test script will interact with the username field, password field, the login button, and the error message. Therefore, the login page object must have fields to represent those 4 elements. Let's create a class by right-clicking the Pages package, New Java class. The convention is to make the web page and our page object class have the same name. So the name is login page. The login page extends the base page. And thanks to inheritance, we have access to the methods inherited from the base page. Click, set, and find. And they will perform actions on the private by username field. Import the by class. They will also perform an action on the private by password field. Private by login button. The get text method will be used for private by error message. With encapsulation, the fields are private. So only methods in this login page have access to the fields. Our page object model should reflect the application. In the application, a different page does not have access to the login button. They do not have access to the username field, the password field, or this error message. So there is no reason for another class to have access to these fields. Now, the other classes would have access to the methods, and we make the methods public. But before we create our methods, let's go back to the AUT and get these values. Inspect username. And it has an ID value of user-name. Inspect password. It has an ID value of password. How about we inspect login? It has an ID value of login-button. When it comes to the error message, let's see what it has in the element. It does not have an ID value, but we see it has an H3 tag. If we scroll up the DOM, we see the parent has an ID value of login button, login underscore button underscore container. So let's find that value by writing hashtag login button underscore container and the tag name, which is H3. Press enter, and we found the element. Let me copy that value and go to the login page object class. Now we're going to enter the values, and I'm going to make room also for the username field. Write equals by dot, and at this point we see the 8 Selenium locators in alphabetical order. We see class name, CSS selector, ID, link text, name, partial link text, tag name, and XPath. We are going to use ID. The value was user hyphen name. For the password field, also the ID attribute, and that value was password. For the login button, by ID, the value was login hyphen button. When it comes to the error message, we're going to use XPath, and I will paste that value. We are finished with the field. Now it's time to create the methods, which will perform action on the fields. There are 4 types of methods we can use in our page object model. We have getter methods, setter methods, transition methods, and convenience methods. A getter method returns the value of an attribute, while a setter method receives a parameter and assigns it to an attribute. The transition method is important when our application changes to a different page. A convenience method is created when combining more than one method into a single method. First, we're going to implement the setter method. Public void set username. The parameter is username. The data type is string. Set the username field to the username we pass in. That's all we write. It's the same with password. Write public void set password. Pass in password. When I write set, notice how the IntelliSense shows by locator, comma, string text. We receive that from the base page. And over here we see it shows base page and it's protected. Select it, and we're going to have the locator as password field. The text is what we pass in, and that's password. The next method, we'll click the button, the login button. It does not have a parameter, but we write click, then pass in login button. And I want to show you something, because I said this here would be a transition method, and transition methods must not have void as a return type. The return type should be what you're going to transition to. And let me show you why it's called a transition method. If I go back to the application and enter a standard user as a username and the correct password, such as secret sauce, then click the login button, watch what happens when I click the login button. The page transitions from the login page to the products page. That's why we call it transition method. Our page object model should reflect the same behavior as the application. For starters, we need to create a products page. In the IDE. I'm going to create a products page by right-clicking pages, new Java class, the name, products page. Press enter, and the products page extends the base page. Now, the access modifier for the login page, we're going to get to that when we click the button. We know it's public because we want the test, every test, to have access to this login button, set password, and set username. But this is what I need to change. And we see it shows products, we see it shows void, but it should be products page. And we notice how a compiler error shows up. A compiler error shows up because we need to return new products page, and that's it. Now we are finished with the transition method for clicking a login button. The next method will be a convenience method, and we're going to name that method public products page, and it will be called log into application. I'm going to pass in string username, string password. It's called a convenience method because it will combine setting a username, setting a password, and clicking the login button into this one login method. Since it's a transition method, it will be a transition method because the final action is clicking the login button. But now, here's what we do next. Call the set username method, pass in username. Call the set password method, pass in password. The final method is to return this click login button method. And that's it. Now, last is the getter method, which will get the error message. I'm going to write public string get error message. Return after finding the error message. Dot get text. We have string as the type because get text returns string. We are finished with the login page object class. Now let's continue with the products page by going back to the AUT and inspecting products. And we see it has a span tag and products is the text. Let's locate this element by writing 2 forward slashes, span, brackets, text, parenthesis equals single quotes, and within the single quotes, let's write products, then press enter. Bingo, we found the element. It shows 1 of 1, and the element is highlighted. Copy this value, and in the products page, we write private by products header. And I'm going to import products header by XPath. Then paste in the value we received when we found the element in the DOM. The method must check whether the products label is displayed on the page after logging into the application. So I'm going to write the method as public Boolean. Boolean is a data type that returns true or false values. The name will be is products header displayed. It returned after finding the products header, and the method is displayed. Boolean is the return type for the Selenium method is displayed. So that's why I have the return type for this method as Boolean. That's it for the products page. And we have finished creating the page object model. Next, we will create 2 test scripts using the page object model. I have a quote from Simon Stewart, which is the person who created Selenium WebDriver. And that quote says, if you have WebDriver APIs in your test methods, you are doing it wrong. The WebDriver API commands are methods like click, clear, get text, is displayed, and send keys. These commands belong in our base page and page object classes. It should not be in our test scripts. However, when it comes to assertions, I prefer to include insertions in my test scripts and not the base page or page object class. There is not a rule that says assertions belong in our test scripts, but I think it is best to keep them neutral in our test scripts. The main reason is because we verify our test scripts and we do not verify the page object class. We will create a test starting with the base test. 2 reasons for creating a base test. First is to set up all test scripts. Second is to close the browser in all test scripts. The base test helps with a programming principle called DRY. DRY is an acronym for Don't Repeat Yourself. We do not have to repeat setting up and closing the browser in each test script. Just do it one time in the base test. Let's create our base test by going to the IDE. And in the IDE, we will create it in the test directory by expanding the test directory, right-click in Java, new package. The package name will be part2.com saucedemo.test. We'll create a base package by right-clicking the test package, new package, but replace test with base. Now we have 2 sub packages under the sauce demo package, part2.com sauce demo. Finally, we create a base test class by right-clicking base, new Java class, the name base test. Now, for the base test, the variables are protected WebDriver, protected base page. Base page is the object reference. Import WebDriver and also import base page. After base page, I'm going to create another variable for the URL. It will be private string data type URL. The value is https://www.saucedemo.com. Now we're going to start with the before class testng configuration annotation. Public void set up. Initialize the driver by writing driver equals new Chrome driver. There are other drivers we can use if we do not want to use Chrome. We can also use Edge. Firefox is available as a driver. We also have Safari available as a driver, but I'm going to use Chrome driver. After creating an instance for Chrome driver, next is to maximize the window with driver.manage.window.maximize. The next step is to load the application by writing driver.get, and we will pass in the URL. After loading the application, let's create an instance of base page. New base page. Now that we have base page, we can set the driver from the base page. Make sure to pass in driver. We need a way for our 2 test scripts to access the login page. Therefore, let me create another variable that's protected, and it is the login page. Bingo. Also import login page. The field is protected, so each test script has access to the login page after inheriting the base test. Create an instance in the setup method by writing login page equals new login page. Next is the after class annotation, and it will make sure to close the browser by writing public void tear down. We can name it anything we want to, but I prefer tear down because we're tearing down the test after each execution. This configuration will automatically execute after each method. Now, this part is where I write driver.quit to quit the driver and close the browser. We are finished with the base test. Next is the login test script. Let's go back to the IDE and create a package by right-clicking test, new package, and I'm going to name the package login. Right-click the login package, new Java class, and the class will be called login test. It inherits the base test by extending the base test. Make sure to import the class. The first test is public void test login error message. Now we write the steps to test if the error message shows up. From the login page, we set username. The username is standard_user. Also, from the login page, we set the password. The password would be anything that's not correct, such as XYZ 3400. Then we click the login button by writing login page.cl. Notice the IntelliSense shows the method click login button and products page. This lets us know that calling the click login button has a transition which returns the products page. Therefore, we assign click login button to a var products page reference. At this point, the assignment for var products page is not required because our test stops when verifying the error message. If we plan to use products page for a subsequent step, then we should keep the assignment. So for now, I would remove var products page. In the test script, we expect an error because the password is not correct. So let's get the error message on the login page. Get error message. Then assign it to string actual message. Why is it called string? Because recall the get error message returned a string after we find the error message. And the error message has a CSS selector value, but I have XPath. So let me correct this to show by CSS selector. At this point, we can go back to the application because we want to see what's in the actual message. So let me go back to the application, and the username is standard user. The password is anything that's not secret sauce. Next, I click the login button, and we see this message contains epic sad face. I would copy, and I'm going to place this epic sad face in the message when it's time to verify. For the verification, let's write assert.assert true. Actual message contains epic sad face. Let's run. We see the test passed with a green check mark. If I change assert true to assert false, then run again, we know the test should fail. But like I mentioned in the introduction, and with the first test, Selenium test, it's always good practice to see what happens when running and expecting a failure. And we see an assertion error that says expected false, but actual is true. Let me change it back to assert true, because I do not want it to fail. That's it for the login test. Next is the products test. Go back to the AUT. No, let's go back to the IDE and create a package for products by right-clicking test login, new package, but replace login with products. Now we have two packages under the test package. Create a class by right-clicking products, new Java class, and the name will be products test. Products test extends base test. The scenario is to test a user can log into the application, then verify the product's header is displayed. So the test is public void test products header is displayed. This time, let's use the convenience method on the login page. We will log into the application by writing the username standard underscore user. The password is secret underscore sauce. Then it transitions to the, let me make more room so it all can fit in the editor. Products page. Import products page. Now recall in the previous test script I wrote var. Either way is okay. But for this, I'm going to have it as products page. After logging into the application, we need to verify the products header is displayed. And I'm going to do that by writing assert true. And products page is products header displayed. We can also call the assert true method directly because it is a test static method. If I hover assert true and click it, we see it's static. So if I wanted to, I could easily come up to the import statement for assert and write dot asterisk, the star, then write static in front of the statement. And by writing that in front of the statement at the end, we can remove assert. Let me make more room. And only have assert true. Either way is okay for the assertion. We can also include a message that will only show up if the test script failed. Let's add a message that says, how about products header is not displayed. Let's change assert true to assert false, then run, so you can see the message. The test should fail with the message that says products header is not displayed. Yes, products header is not displayed. We know it is displayed, so let me go ahead and correct that from assert false to assert true, then run again so we can see it pass. As expected, the test passed. That's it for part 2, creating a page object model. Next, in part 3, we will work with WebElements. Welcome to part 3, working with WebElements. A web element is an element on the web page. An element is defined in the DOM with tags, attributes, and attribute values. So in this part, we will start by scrolling to a web element using JavaScriptExecutor, followed by working with radio buttons. Next is checkboxes, then drop-downs. After drop-downs, we will work with tables, links, and dates. Before working with web elements, let's go over the AUT, base page, then I will create the base test. The AUT for parts 3 and 4 is demoqa.com. This is the home page for the AUT, and it has 6 cards: elements, forms, alerts, frame and windows, widgets, interactions, and bookstore application. For the automation project, I will use the same base page. It contains a method for setting the driver, finding the web elements, setting the values, and clicking the elements. I will create the base test from scratch after creating the home page. When it comes to the home page, I will first set up the package by right-clicking Java in the main directory. New package. The name is com.demoqa.pages. right-click the package. New Java class. Name is home page, and it extends base page. Now let's create the base test by going back to the project, right-clicking Java under the test directory. New package. This package will be called part3_4.com.demo QA. Right-click this package. New package. This name is base. At this point is when I create the base test class. Right-click, new Java class, and the name, base test. Okay, so at this point, we can go ahead and write the variables in the base test, starting with private web driver, protected base page. After this part, I'm going to write protected home page. And each one of these have to be imported. So starting with WebDriver, next is base page, last is home page. I will also create a variable for the URL, private string. The name is demo QA _URL, and paste in the URL. Next, we will set up each test, load the application, and tear down the test. Set up the test with test.ng annotation before class. Public void setup. Driver equals new Chrome driver. Before each class, our test will communicate with the Chrome browser. Let me also driver.manage.window.maximize so we can make the window browser bigger. Before each class is now set up for Chrome browser. Before each method, our project will load the application. Public void load application. And it's going to load the application with that driver.get method. Pass in demo QA URL. Create an instance for base page. New base page. After base page, we will set the driver. Base page dot set driver, then pass in driver. Since every test must go through the home page, we will create an instance for home page. Last is after class, the other test.ng annotation. It will tear down after each test class. It will close the browser with driver.quit. That's it for the base page, home page, and the base test. First up is the JavaScript Executor tutorial session. The purpose of JavaScript Executor is to indicate a driver can execute JavaScript. We can perform many commands using JavaScript. However, our focus will be to scroll down a page to an element. From the top of the AUT web page, notice how we are not able to see the names of each card unless we scroll down the page. Then we see the names of each card. Let's focus and start with the forms card. Inspect, and it has an H5 tag with no attributes. But if I scroll up the DOM, the ancestor has a div tag with an ID attribute set to app. I will define the forms card by first finding the ancestor. So in this search HTML bar, I will write 2// div square brackets at ID equal to 2 single quotes. Within the quotes, I put the same value that's in the element app. Watch what happens when I press enter. The ancestor is highlighted. The highlighted portion means that we have found this element, and it shows 1 of 1. Now let's proceed to finding the forms card by writing 2/ and a tag name of H5. When I hit enter, we see it shows 1 of 6. 6 means there are 6 elements that match this value. And those 6 elements are the 6 cards on the home page. Right now, it's set at elements, that's 1. If I press enter, it shows 2 of 6. 2 is the second element, which is forms. If I press enter, it goes to the third element that match 3 of 6, and that is alerts, frame, and windows. But to be more detailed, let me write square brackets, text, parenthesis equals 2 single quotes. And within the quotes, that's when I write forms and press enter. And it switches to 1 of 1, and it goes to the forms element. Let me copy this value. Then click the forms card to show you that the page transitions from the home page. Now going back to the home page object, let's write private by forms card. We found the element by XPath, and I would paste in the value. At this point, we will go to the forms page by writing public forms page. The method name is go to forms. The body will be click forms card. Then return new forms page. Forms page is red because we have not created a page object model for forms page. So let me copy forms page, the name, and go to the project and create a forms package and a forms page object class. Go to the main directory, Java, then right click demo QA.pages. New package. Forms is the name. Right click the forms package, new Java class, then paste in forms page. Forms page extends home page. And we see 2 related problems. The 2 related problems are due to the 2 red markings on the home page for forms page. But since we now created the forms page object, I will import the class for forms page. Going back to forms page, the 2 related problem goes away. For the test, we go to the test directory, Java, and then we right-click part 3 for package. And I will create some packages. New package. This time I will create the test package, but replace base and then write test. And we see 2 sub packages under part 3.4. Now I will organize the test package into the different parts, part 3 and part 4. Although we have not started part 4, I'm going to go ahead and still create the package. Part 3, right-click, new package, change 3 to 4, and we see part 3 and part 4. Now, back to our JavaScript test. I'm going to right-click part 3, new package, and then place JavaScript package, and we're going to have the JavaScript test. And this test, when I refactor and make sure to add test at the end, this JavaScript test extends base test. But notice there is more than one base test. We see part 3, 4, and part 2. We need part 3, 4. And the test will be public void test scrolling to element. And let me make some room on this editor. And we're going to start with the first execution, but let me show you what happens with that scrolling to an element on the page. So first, I'm going to make sure to fail this test by writing homepage.goToForms. It's going to fail with an exception of element click intercepted exception. Yep, we see the failure. And we see the console shows element click intercepted exception. This exception means Selenium is trying to click an element, but there is some kind of interference. Most of the time, the element is blocked by a different element, or we cannot see the element on the web page. Before clicking the forms card, we must scroll to the element using JavaScriptExecutor. Let's start by creating a utility package. Right-click Java in the main directory. New package. Name is utilities. Next, I would create 2 utility classes. When it comes to utility class, the purpose of a utility class is to complement other classes by providing methods for executing common routines. It is not required, but it is good to include in our project because they operate like global purpose classes to help the page object class and the test classes. Right-click utilities, new Java class. The name is utility. In this class, let's write public static web driver. Then import WebDriver. Now we need to set the driver by writing public static void set utility driver. Within the body, let's write driver, and it gets its assignment from base page dot driver. This utility class can also include methods like generate a random number, or something like return strings to uppercase. Just give you an idea what else can be included inside this class. If you want to, you can also organize your class into different type of subclasses, utility package. But for this, I would organize it into another class called JavaScriptExecutor methods. New Java class. You know what? I just would name it JavaScript utility. And this class extends utility. The method name is public static void. Scroll to element JS. JS is something for JavaScript to let us know what kind of method it is. First step is to find WebElement. Element is the reference. Driver.findElement, and I'm going to pass in the locator. But let me go back here and put locator as the parameter. Import the by class and also import WebElement. Next is a string named JS script. Within this string, let's write arguments, square brackets, 0, dot scroll into view, then write parentheses, followed by a semicolon. At this point, we typecast JavaScript Executor. When we typecast JavaScript Executor, the driver can execute the script when passing in JS script, comma, element. That's all we need for the driver to execute JavaScript and to scroll to an element. Let's go back to the home page object. Then write scroll to element JS. And it's going to scroll to the locator forms card. Import the method. Bingo. Next, the base test. We'll call the set utility driver method after calling the base page set driver method. We write set utility driver and import the method. So now we have set up the utility driver. Let's run again. Bingo, we saw the test pass, but the execution was fast. So for demo purposes, let me add a sleep statement to the base page. On my projects on the job, I do not add the sleep statement to the base page. But for this demo, I'm going to go to the bottom and I'm going to add a sleep statement. And the name will be public static void delay. Pass in milliseconds as the parameter. And how about a try catch block? And within a try catch block, I will write thread.sleep, then pass in milliseconds. Let me add some more room so we can see the complete part of the editor. Catch, and I'm going to write interrupted exception. exe.print stack trace. Now, I'm going to call this delay method from the base test before driver.quit, only because I want you to be able to see the execution so it don't go so fast. It's going to delay the process for 3,000 milliseconds, which is the same as 3 seconds. Import delay. This time, we should see the forms page and the test pass. The test passed, and we saw the base, we saw the test. Now, there's one more thing I want to do. I added this delay to the base page, but I want to separate this base page and not place it inside of the source demo package. I'm going to create its own package the same way I created it for the base test. So I'm going to right click, come, new package, and then write one more time, right click, come, new package, and then call it base. And then drag the base page to the base package. That way it's more outside of the pages that I did for demo QA and sauce demo pages. It would have worked inside sauce demo like we saw a moment ago, but I just want to structure it so it's more organized. And if I run again, you will see that it will pass. Now, that's it for scrolling to an element using JavaScriptExecutor. Next, we will work with radio buttons. In a web page, a radio button is a circle, and it is selected when it is highlighted or filled out. For example, when I go to the AUT, we see 3 radio buttons. They are circles. And when I click impressive, it is blue, highlighted blue, and it is filled out. In some applications, you might see a response like you have selected impressive. The test script will click forms on this home page, then click practice form. On this practice form page, Selenium will click one of these radio buttons, like mail. There is no response after clicking the mail radio button, but we will verify the button is clicked using test-ng. In the previous tutorial, I created a home page object class that clicks the forms card on the home page. The forms card provides access to this practice form page. So let's inspect the practice form menu item. Make it bigger, and this DOM shows the span tag has a class attribute. The parent is li, which means list item, and it has an ID value of item 0. So when I find the element, I'm going to find it by first locating the parent element by combining 2 of those elements. So let's write 2 /li square brackets at ID equals item 0 hyphen 0, because that is the value of the parent element, followed by /span. Within the span brackets, I'm going to write text parenthesis equals. Now I write practice form. Bingo. Got the element. I'm going to copy the value and go to the forms page object class and start by writing private by practice form menu item. We found it by XPath. So let me paste in the value. The method is public practice form page. The name of the method is click practice form. The body of the method will first scroll to the elements using JavaScript. Then I will pass in the locator. Also, let me highlight this part because that's the JavaScript method to scroll to the element. After scrolling to the element, we click the element. Practice form menu item. Then return new practice form page. We see red because the page object has not been created yet. So let me go to the forms package, right click, new Java class, paste in the page object. And the page object extends forms page. Yes, now we have the practice form page object. On the practice form page in the application, our test script would click female. So let's inspect female. It has an input tag name and an ID value of gender-radio-2. Copy this value and I'm going to find it with the hashtag and paste in the value. Yes, we found the element. So now I'm going back to the IDE and begin by writing the field. Private by female radio button by ID is how it was found. Paste in the value. And don't forget the semicolon. The next step is to click the button. We click the button by writing public void click female radio button. And we're going to do the same thing by scrolling to the element using JavaScript. Female radio button is the locator. Then we click the female radio button. Let me import this method. Yes, at this point, the page object is complete. Now, let's write the test by going to the test directory, right-clicking part3.javascript, new package. The new package name will be forms. So let me replace JavaScript and write forms. Now, right-click forms, new JavaScript. The name of this class will be, how about radio button test? And radio button test extends the base test. Import from part3_4. This test will be named test radio button. Yes, so I'm going to create an object reference named, how about forms page. And on the home page, we go to forms, then click practice form. On the forms page, we click the female radio button. Let's run. This test will fail, and I will explain why it will fail when we see the exception. Yes, it failed with an element click intercepted exception. In most applications, the Selenium WebElements click method works, but sometimes it does not work. If I go back to the practice form page object class, the statement shows click female radio button. I need to replace this click method with the JavaScriptExecutor click method. Then the test will pass. So let's go to the JavaScript utility class and create a method to click from JavaScript. Public static void click.js. Pass in a by locator, and this is how we will create the method. I will start by writing WebElement, and I'm gonna create it a little different from how I did it up here. WebElement equals driver.findElement, passing the locator. A different way we can do it is by writing JavaScriptExecutor, give it a name like executor. Now we write JavaScriptExecutor, and I'm going to write driver, and that's it. On this next line, I will write executor.execute script. The value is arguments brackets 0 dot click parenthesis semicolon comma element, and that's it. This is how we click an element using JavaScript. Now let's go to the method, and I want to show you what I will change when I go back to practice form page. Click will change to click.js. That's it. So now when I run again, it should pass. Yes, it's green, and we see pass equals 1. On the practice form page, the next step we need to do is verify the button was clicked. So I'm going to write public Boolean. The return type is Boolean because we expect a true or false value to be returned. Is female radio button selected? I'm just going to put is female selected. Return after finding the female radio button, and I'm going to put a dot operator is. Selenium shows these 3 Boolean methods: is selected, is enabled, and is displayed. We need is selected because we're going to check to see if the radio button is selected. Now let's complete our test by going back to radio button test. And after clicking the female radio button, I will write forms page dot is female selected. And since it returns a Boolean value, we assign it to a Boolean value, and let's name it is female radio button selected. The assert statement is the last step, and let's see if it is selected. Also add a message that says female radio button is not selected. Let's run. Yes, it passed. If you want to see the test fail, just change true to false and run again. Now, the female radio button was clicked when I used JavaScript click. Sometimes JavaScript click does not work. Therefore, I recommend to go to the base page and wrap the click method to combine the WebElements click method and also the JavaScript click method. So one of them will work. And we see the failure, although we know that the test passed. Let me change this assert statement back to true. That's it for working with radio buttons. Next, I will show you how to work with checkboxes. A checkbox has a square shape. One or more checkboxes are selected when it is highlighted or filled out, just like the radio button. In that way, radio buttons and the checkboxes operate the same. But let me show you the difference between both elements. In our AUT, the test script will click all three of these radio buttons: sports, reading, and music. Then uncheck the reading checkbox. Here is the difference between radio buttons and checkboxes. When I click the male radio button more than one time, it remains selected. However, if I continue clicking the reading checkbox more than one time, it is selected, then not selected. Therefore, it is best to add a condition to see if the checkbox is selected before we click it. In some applications, a checkbox may be selected by default. If it is selected by default, then we should not check the box. Inspect sports, and let's see what the DOM shows us. When I inspect sports, it has an input tag with an ID attribute of hobbies -checkbox -1. Let's locate that element with hashtag, then paste in the value, and we see the element. If I inspect reading, it has an ID value of 2 at the end. How about music? It has an ID value of 3 at the end. So if I change 1 to 2, it's going to show us the middle checkbox, which is reading. If I change 2 to 3, it will show us the third checkbox, which is music. Okay, so we have the value to find the elements. Let's go to the forms page object and write in those fields. Starting with private by sports, hobby, checkbox. We found it by ID and paste in the value. Now I'm going to copy and paste the field, change 1 to 2, and also change sports to reading. And do the same thing for the third field, and that's changing sports to music. For now, we can go ahead and write the methods. The methods start with public void click sports hobby checkbox. And this part is where we add the if condition with an exclamation point. Exclamation point means not. Find the sports hobby checkbox. Is it selected? If it is not selected, let's scroll to the element. Which element? Sports hobby checkbox. After scrolling to the element, we click the element. And that's it. When Selenium finds the sports hobby checkbox and it is not selected, then it's going to scroll to the element, then click the element. Let me change this here a bit to make it just show click sports checkbox. So now we have completed the first method. I'm going to copy and paste this method 2 times. And we're going to update the second method from sports to reading in all 4 locations. That's the 3rd location, and that's the 4th location. And for the next one, I'm going to change sports to music in all 4 locations. 1st location, 2nd, 3rd, and now the 4th. We have 3 methods for clicking each sports, music, and reading checkbox. Now I'm going to write the method for unclicking the reading checkbox. So let me copy and paste the reading method. Then make 2 changes. First change is going to go from click to unclick. Then I'll remove the exclamation point. So this method is saying if this here checkbox is selected, then we scroll to the method, then click the method. The last method is to verify the reading checkbox is not selected. And for that, we write public Boolean is reading selected. We're going to return it, the value. But first we find the reading hobby checkbox. Is selected. And that's all we need to see if the reading checkbox is selected. Now, let's go ahead and write the test. By right-clicking the forms package, new Java class, the name of the class will be checkbox test. And the checkbox test extends base test. And we import part 3_4. Okay, so for starters, we have to make sure to add the test annotation. Public void test checkbox is the name of the method. Now, we're going to have the reference be forms page. On the home page, we're going to forms. Then we click practice form. On the forms page, we're going to click sports checkbox. After clicking the sports checkbox on the forms page, we're going to click the reading checkbox. Finally, we click the music checkbox. Now, there's one more thing we must do, and that is to unclick the reading checkbox. So on the forms page, unclick the reading checkbox. And at this point, we are ready for the verification. On the forms page, is reading selected? And since it returns a Boolean value, true or false, we assign it to a Boolean value. And I'm going to name it is reading checkbox selected. Assert false, because if it is not selected, it should be returning a false value. Is reading checkbox selected? If it is not selected, then let's write this message. Reading checkbox is selected. Now let's run. I'm expecting to see the reading checkbox not selected on the AUT. Yes, reading is not selected. And we see the green check mark. At the bottom, it shows pass. That's it for working with checkboxes. Next, we will work with tables. A table consists of a header with rows and cells. In most applications, a table is defined by the table element. Within that table element, we normally see child elements TH, TR, and TD. TH identifies a table header. TR identifies a table row. And TD identifies a cell in the table. However, in this application, when I inspect the table, we will see different elements, but still representing the table elements. So within this, we see many div tags, and we see classes representing table, RT-table. Next, we see a class representing the header. It shows RT-head-header. Next element, which is a child of the header, we see row. And within the row, we see TR. If I inspect a cell in the table, like Vega, we see the class shows TD. Now, it does not matter because it's still a table element. It's just they design the application different with different elements. Our test script will click elements from the home page. After clicking elements from the home page, it will click the web tables menu item. And at this point, Selenium will edit a row like Vega by clicking the edit button. Then update the age to a different number, then submit the form. And we see that it was updated to 45. Now, since both of these has 45, I'm going to design a test script to be a different number. Now, after updating that part, the age, we're going to verify the age. So let's go to the home page object and home page and inspect elements. When I inspect elements, we see it has an H5 tag. But if I scroll up the page, the parent has a div tag with an ID value of app. So to find the elements tag element, we're going to write 2/ div and then write @ID equal to app. Following app, we're going to write 2/ H5 tag name text equal to the name of the card we want to find. And yes, we have found the element. Let me copy this value and now go to the home page object. In the home page object, I'm going to create a field by writing private by elements card by XPath is how we found the element. Paste in the value, then write the semicolon. Now for the method, I'm going to write public elements page, and the name will be go to elements. The body will first scroll to the elements card, then click the elements card. Next, it will return the elements page, a new elements page. Now, let's create the page object for the elements page. But first, we must go to demoqa.pages, package, right-click new, and create a package for elements. Now, within the elements package, let's create the page object elements page. And the elements page extends home page. Let me now go back to the home page object and import the elements page object. Bingo. So now we have taken care of the home page. Let's go back to the AUT. Next step is to click the Web Tables menu item. So let's inspect Web Tables, and we see the parent has an list item tag name with the value of item 3 for the ID. Next, we must find the span tag. And to find it, let's start by first locating the parent with li at ID equal to item -3. Yes, found the elements. So now we find the span tag, which contains the Web Tables menu item. Within single quotes, we write Web Tables. Yes, and it found the element. So let me copy this value and go back to the elements page object. And within the page object for elements, I create the field by writing private by Web Tables menu item, and then paste in the value for XPath. Now, after the field, we create the method. Public, how about we name it public Web Tables page, will be the elements page when we get to it. The name is click Web Tables. And the action will click the Web Tables menu item. And must remember to return new Web Tables page. At this point, we create the Web Tables page object by going to the project. We right-click the elements package, new Java class, and the name is Web Tables page. The Web Tables page extends the elements page. Now, let's go to the Web Tables page in the application. And we're going to inspect the edit button for Alden. So let me right click, inspect, and let me inspect one more time the edit button. Yes, the span tag has an ID value of edit hyphen record hyphen 2. On the project, I would not recommend using this ID value unless it remains a unique value. However, this value can change if another record gets added to the table. So we can use the title attribute, which has edit as a value, with a unique value like email for Alden at example.com. Then traverse the DOM to find the edit button. Let me show you by first finding the email by writing div tag. Let's first go to and show you how it is in the element. So in this application, we see it shows div tag and Alden at example.com. So let's first find this value by writing 2/ div text and then paste in the value. So we have found the email. Now traverse the DOM by writing what follows the email. And what follows the email is the edit button. And the edit button, we write following, it had a span tag. And after the span tag, we write at title equals edit. Yes, and we found the element. So let me copy this value and then go back to the IDE. For Selenium to locate the edit button, we need to pass in an email. So we will only create a method and not a field this time. We create a method because the email can change depending on which record we prefer to update. So I would write public void click edit. At this point, we pass in a parameter, which is string email. And that's the value our test will pass in. And it will be flexible to locate any edit button according to what value we pass in for the email. So we write by edit because it's going to be a by locator, by.xpath because we found the element using XPath. Now at this point, the value for email is hard coded, Alden at example.com. So we remove the hard coded value, write 2 double quotes, 2 plus symbols, so we can append the parameter email. Now that we have found the element, we write click edit because that's what we're going to click the edit button. That's it for clicking the edit button. After clicking the edit button, our test will set the age. And it will set the age for the registration form. So now let's inspect age. And we see it has an ID value of age. Okay, now we inspect the submit button. The submit button has an ID value of submit. Okay, got it. To create the fields in the web tables page, we write private by registration age field. And we found it by ID. And that ID value was age. Next is submit button. And that was located by ID with the value of submit. Now we have the fields for age and submit. We must write the methods. The method first up is going to be for the age. And that is public void set age. And I'm going to pass in a parameter of age. Now we set the registration age field with the value of age that we pass in from the test. Next is the submit button, and we click. We right click, the locator is submit button. At this point, let's go ahead and create our test and run it. First, I go to the test directory, and I'm going to go to the part 3 package in the test package. Right click part 3, new package, and the package name is elements. Right click elements, then we create our class, web table test, and it extends base test from part 3, 4. Now we have our class. We're going to create our test, and the name will be public void. How about test web table? Let's create the var, the variable, and the name will be, how about we name it anything such as web table page. On the home page, we go to elements, then click web tables. On the web tables page, we start by clicking the edit button. And the value we pass in for email is alden@example.com. After clicking the edit button on the web tables page, we set the age, and the age is 34. Then we click the submit button. Let's run. The test passed. Good. For verification on this page, we need to inspect the age for Alden. So when I inspect age, we see the DOM has age. But based on how the table is designed, I will first find email like I did for clicking the edit button. And after finding email, I'm going to locate the age, which precedes email in the table. So to find it, I will keep the same value where I found email. But instead of putting following, I'm going to put preceding. And it has a div tag and not a span tag, because we see here the tag name is div. Within the div tag, write the brackets, and I'm going to write that it precedes one index up. So within the div tag, I'm going to write 1. And we found the age element. Now, if you can, try to avoid using indexes like 1 when locating an element, because an index can change. If it changes, then the test will fail because Selenium can no longer locate the element. However, there are times when you may need to locate the element using an index. So let me copy this value. And now in the page object, I'm going to write public string get table age. And I'm going to also pass in how we found the table age is by XPath. And just like the previous method that used email, I'm gonna change the hard-coded email to an email the test pass in. Let me also set up the parameter. So now that we have found the element with the by locator, next is to return the value after finding table age. We return it by getting the text. Now that we have replaced the hard-coded value with emailed, now I'm going back to the test to verify the table age. And that is on the web table page, get the table age. What age are we expecting? We're expecting an age of 34 after we pass in the email. Bingo. So now we're going to get the table age, but it will be assigned to string actual age. Now we have returned the actual age. Next is, what do we expect? The expected age equals 34. For the assertion, we're going to assert that it equals actual age and expected age. I'm going to also create a message. And the message will say actual and expected ages do not match. Now let's run. Yes, the test passed. We can also create a variable in the test and assign in the email. For example, at this point, we have two statements that have email. I can create a variable, which is a string. Let me create it on the first line, which is a string email, and assign a value. And rather than writing the hard-coded value in both places, replace it with email to take care of it. I can also take this expected age at the top, and we can run again. You know what, this time, let me change the email to a different email, because we saw how it updated Alden at example.com. This time, let's update Kiera at example.com. And run again. The test passed. That's it for working with web tables. Next, we will work with links. A link is short for hyperlink. In a website, a link can be a word. It can also be an image that activates when we click it. After clicking the link, the application will trigger some kind of response, such as navigating to another location. The location can be a different part of the same application or a different website. Our AUT will be this links page under the elements card. The test will click bad request, then verify this response. Link has responded with status 400 and status text bad request. There is a typo with the first status. The test steps will click links. So let's inspect it. And we see there is a span tag with links as the text. However, the parent tag has an li value with the value of item -5. So we find it like the other values. There was a menu item, 2 forward slashes at ID inside of the square brackets, then the value item -5. Now let me fix this here because I did not write li, and that's why it's red. Now we found the item, the element, / span. And within the span tag, write the brackets, text, parentheses, and within the single quotes, we write the text of links. Yes, we found the value. Now let me copy the value and go to the elements page object. For the page object, I'm going to start by creating a field private by links menu item by XPath. Paste in the value. For the method, we write public. How about links page as the page object name, and the method name will be click links. Within the body, click the links menu item. Make sure to return new links page object. Let me copy the links page, and I'm going to create the page object by right-clicking the elements page, the package. And I'm going to make it a class and paste in the value. Now the links page object extends the elements page object. At this point, we have created the links page object and extended the elements page. Now on the elements, on the links page in the application, let's inspect bad request. And it has an ID value of bad -request. Let's also inspect the response. And it has a value of link response inside of the P tag name. Now, let's go back to the page object for links page and create the fields. The field is private by bad request link, and we found it by ID. The value was bad -request. Next is the response link. That value was response link response. For the methods, our method will click the link and get the response. So we write public void click bad request link. Click the bad request link. Next, we get the response by writing public string, because we're getting a value that is a string. And we're going to first delay, because there was a delay right before the response showed up. So the delay will be 2,000 milliseconds, which is the same as 2 seconds. Next is return the response after Selenium find link response or response link. Now we get the text. And know what? Before clicking the bad request link, let me first scroll to the element. Bingo. And also import the method from the JavaScript utility package. Now, that's it. We are at the point where I can now write the test. So I'm going to the test directory, part 3, within the test directory, test package, right-click Elements, New Java class. And the name of the class would be links test. And links test extends base test. Make sure to import from part 3, 4. Let me also make a little room. Now, our test will be public void test links. Also, we create a reference by writing var links page. And on the home page, we go to elements, then click links. On the links page, we click bad request link. After clicking the bad request link, next is to get the response. Then assign a response to a string, because get text returns a string value. We'll assign it to actual response. Bingo. This one assertion will verify 2 parts of the response. It will verify if the response contains 400 and also verify if the response contains bad requests. If I go to the application, we see 400 and bad request boldface. So that's what our assertion will verify. Therefore, I write assert true. Assert true that the actual response contains 400. And actual response contains bad request. Let me bring this over some. Bingo. Now, after that, let's go ahead and write the message. And I will write the message on the next line. The message will be actual response. I'm going to make this here have parentheses and then pass in the actual response. On the next line, let's write, close the parentheses, and now let's write actual response. How about does not contain 400 and bad requests. Just making the message detailed. Now, let's run. Know what? Let's make the first test fail on purpose so we can see the message. Let me go ahead and make this here assert false, just to see what the message shows when we run it. It failed, and the message says, actual response. Link has responded with status 400 and status text bad request. Does not contain 400 and bad requests. Okay, so it failed, and we see the message. So it was a true failure. If it was a true failure, we will see that response. And with the response do not contain. So now, let's go ahead and pass it by changing assert false to assert true. Bingo, it passed. we see the green check mark, and it shows pass 1 with run 1. That's it for working with links. Next is working with drop-downs. A drop-down allows us to select an option from a list of options. In some applications, we can select more than one option from the drop-down. In the AUT, you will see how most drop-downs are defined by the select tag. If I inspect old style select menu, we will see how the tag name is select, and it has an ID value of old select menu. If I inspect select standard multi-select, we see how it also has a select tag. Now, it's different for some drop-downs because when I select multi drop-down, this has a parent tag of div. When I expand the div tag, we see that there is an input tag name. Input allows us to set the values into the dropdown the same way we can set the name in the element that is input. We can operate the same way with this dropdown. So this dropdown is flexible to input values and also select values, because if I click the drop-down arrow, we see there are options to select. Our test script will select from the home page the widgets card, then go down to select the select menu item. On this page, the test will select more than one option from this standard multi-select dropdown. So let's go back to the home page and inspect widgets. It has an H5 tag like the other cards with the different name of widgets. If I scroll up the DOM, it has the same parent with the div tag ID set to app. So to find this element, write 2/ div square brackets at ID equal to app. Now we traverse the DOM by writing 2/ H5 tag name text parenthesis equal to widgets. Bingo, found the element. Let me copy the value and go to the home page object and write private by widgets card. We found it by XPath, so paste in the XPath value. Next is the method. The method is public with a return type of widgets page. The name is go to widgets. When we get to the home page, we will scroll to the element, which is widgets card, then click widgets card. Next is to return new widgets page. At this point, let's create the page object, but first we must create the package, and we create the package by right-clicking demo QA.pages. New package. The package name is widgets. Now that we have the package, we're going to create the page object, and the page object is new Java class widgets page. Widgets page extends home page. We see those two related problems because we have not imported widgets page. Now the related problem goes away. In the application, let's inspect the select menu on the left side. It has a span tag, but the parent is list item, LI. So we first find the parent because it has an ID value, LI at ID equal to the quotes, item hyphen 8. Bingo. Now we find the element by writing span, text, single quotes, select menu. Bingo. Found the element. Copy the value and go to the widgets page object. In this page object, I'm going to write private by select menu item by XPath and paste in the value. Now we access the menu by clicking the menu. Public select menu page, and the name, click select menu. This gives us access to that page. Now we scroll to the element using JavaScript. Select menu item. After selecting the menu item, when we scroll to it, we click the select menu item. Let me import the static method. At this point, we can create the page object after I return with the transition. Go to the project, right-click widgets, new Java class, and paste in the select menu page object. Select menu page object extends the widgets page. Bingo. Now we can go ahead and continue by going to the application, inspecting the standard multi-select dropdown. And it has an ID value of cars with the select tag. Notice it has an attribute called multiple. This indicates we can select multiple options from the dropdown. Let's create a field and a method. The field will be private by standard multi-select by ID. We found it with cars as the value. And the method is public void select standard multi. In Selenium, there is a separate class for selecting an item from the dropdown if the dropdown contains a select tag name. When it contains a select tag name, then we start with select. Select is a class, so that's why it is red at this point. So let me import the class. And after importing the class, we see it is still red. That's because we must also add a reference. The reference can be any name, like select equals new select. Working with dropdowns requires us to find the dropdown, then pass what we found to the select class. So we have wrote this reference name, but now we must write find. And what did we find? We found the standard multi-select dropdown. We use the select reference with the dot operator. The dot operator provides access to 3 methods that we can use from Selenium to select an option. Write select by. And we see select by index, select by value, and select by visible text. In my opinion, select by visible text is the most popular method for selecting values from a dropdown. So we can also deselect by visible text, deselect by value, and deselect by index. Let's go to the application and look at this select tag. The select tag has child elements, and they are beginning with an option tag name. We see 4 option tags. It has a value attribute and it has text. The value attribute has values that begins with a lowercase letter, Volvo, Saab, Opel, and Audi, while the text has uppercase letters with the same names, Volvo, Saab, Opel, and Audi. On the page, inside the drop downs, we see Volvo, Saab, Opel, and Audi in uppercase. Those are the same values from the DOM. That's how we implement the Selenium select by visible text method. To use select by value method from Selenium, we find the value, which are lowercase, then pass in the value. Depending on the dropdown, you may come across numbers as the value attribute. For example, if I inspect red in the old style select menu, expand the dropdown, and we see there are numbers as the values 1 through 10. If I wanted to select blue in the dropdown, then I will use value 1. When it comes to the Selenium select by index method, we must consider how indexes are 0 based. That means all indexes start with 0. So for this dropdown, an integer of 0 would select red. Integer of 1 would select blue. When it comes to the standard multi-select dropdown, with indexes, if I wanted to select Volvo, then I would use index 0. In the IDE, let's go ahead and complete this method by writing a parameter so we can pass an argument from the test. The parameter will be string text. Then write select by visible text and pass in the text. This is all we need to select an option from a dropdown. Before this select statement, let's scroll to the element using JavaScript, standard multi-select. Also import the scroll to element method. On my projects, I create a utility class for select options because there is no reason that we need to write this redundant code over and over. We can call it one time from the utility class and use it in all classes. But for this tutorial, you will see how it will be easy to just call a method from the utility class. We create it by right-clicking utilities, new Java class. And we're going to begin by writing the name, and that will be drop down utility. And this class extends utility. Also, let's write this private method that's static and it has a return type of select. The name will be find dropdown that passes in a locator. Import the select class and the by class. It's going to return new select, and we're going to use driver to find the element and pass in the locator. This method is private because only methods in this class will use this method. Other classes will not use this method. So that's why it's private. The next method is public because we're going to call it from other classes, such as the select menu page object class. So I write public static void select by visible text, pass in the by locator string text. Let me also make some more room. Okay, so for the body of this method, I begin by calling the find drop-down method that's in this class. Pass in the locator dot select by visible text, then pass in the text that we want to pass in. That's it for that method. Now watch how I'm going to create other methods, such as one for select by index. Change the name from visible text to index. Notice there is an error. There is an error because select by index requires an integer, and this has string data type. If I go to select by index, we see that it requires int index. Select by value is string value. Select by visible text is also a string. So going to the drop down utility class, I'm going to change string to int and rename this text parameter to index. And I'm finished. You know what? I can go ahead and make the same for value, select by value, but this will be string value, and also change this to value. Watch how better it is to just call the method from the utility class. I'm going back to select menu page and just write the value of the method and pass in the information. What's the locator? The locator is standard multi-select, and write in text. Also import the method. And since I would use more than one method from that utility class, I'm going to change it to an asterisk, a star, so I don't have to import any more from that class. So now I'm going to comment lines 15 and 16 because I do not need it. This one line performs the same operation as these two lines. Now, I'm going to create an overloaded method in this page object class. And to create the methods in this class, start by copying and pasting this select standard multi. I will not create a method for value because it will still give us an error. For instance, if I change this here to select by value, and I change string text to string value, we still have a compiler error because the parameters still have the same data type as string. Let me hover and it shows an error. But if I change this here parameter to an integer and rename it to index, there is no error. When I change select by value, which plan to receive a string, to select by index, which receives an integer, now we see the error goes away. But this is overloaded. Select standard multi. So these are the two methods we use in the test. And for the test, let's go ahead and create it by going to the project, standards directory, part 3, the test package, and right-click part 3, new package. The package will be called widgets. Right-click widgets, new Java class. The class is scroll, select, drop down, test. And it extends the base test from parts 3 and 4. At this point, we go ahead and create our test. Public void test drop downs. How about we put it as test multi select drop downs, because we're going to select more than one option from the drop down. Also make more room so we can see what's written on this editor. Now, on the home page, we go to widgets and click select menu. Assign this to var select menu page. Let's go back to the AUT to see the options. We have Volvo, Saab, Opel, and Audi. Okay, so on the select menu page, we're going to select standard multi Volvo. Next, we select the second option by writing select menu page, select standard multi 1. 1 selects the second option. Now, we do not have to select options in order. For example, the third option was Opel and the fourth option was Audi. I can write select menu page, select standard multi Audi as the fourth option. And when we execute the test, you will see how the test will select 1, 2, 4, then 3. The next one is select menu page, select standard multi, and this time I will select the third option, which is 2. Let's run right quick and see the execution. All 4 options were selected in the drop-down. And it selected the fourth option before the third option. The same concept applies for deselecting an option. We go to the drop-down utility class. Since we implemented and used select by index and select by visible text, for deselect, I'm going to use deselect by value. And we do that by writing public static void deselect by value, pass in a by locator, string value, find the drop down with the locator, call the deselect by value method, then pass in value. That's all we need. Now we go to the page object. And in the page object, we write public void deselect standard multi and pass in a string value. We're going to scroll to the element. Which element? Standard multi-select. And we're going to then deselect the value. What value? We need the locator first, which is the standard multi-select, and the value we pass in. Bingo. Now in the test, we're going to write select menu page dot deselect standard multi. Which option? Well, the values were lowercase letters. Let's go ahead and select sob, which is lowercase. I'm going to run, and sob should be deselected after it is selected. Yes, it's deselected. And a test pass. There are different ways to verify values in the dropdown. Let me show you how to verify all of the selected values from the dropdown. Go back to the utility class, and I'm going to write public list string as a return type. The method name is get all selected options, and I'm going to pass in the by locator. First step, we must import list from java.util. Then we find the dropdown by passing in the locator. .get. Get now pulls up the options in IntelliSense that allows us to get options from the dropdown. And we see get all selected options, we see get first selected option, and we see get options. Now, notice how get all selected options return list WebElement, and get options return list WebElement. That's why I have list string as return type, because it returns a list of WebElements. The difference between get all selected options and get options is get all selected options select all options that were selected. Get options select all options in the dropdown. It does not matter if it is selected or not selected. Next is get first selected options. This method select the option that was selected if you only can select one option. So when you select an option, this would get that element. If I write is m, we see is multiple. This method confirms if the dropdown selects more than one option. I would implement get all selected options. Then assign the value to list WebElement, because that's what it returns. Let's name this all selected options. Let me make room so we can see everything on this editor. Now, it's not letting me import WebElement, but we'll come back to it, because sometimes the IDE does not always show what can be imported. Import org openqa.selenium WebElement. Had to manually import it because it did not come up by default right here. Let me make that room. Okay, so now for the all selected options, we're going to return stream.map. And it's a WebElement. Two colons, get text. Next is to collect. And within the collect method, we're going to write collectors.toList. And we import collectors. So collect collectors, and it's not letting me import. And I'm not sure, but I will come back to this part where it's not letting me import collectors, because we will have to maybe manually import it. Let me try one more time. Okay, so I'm going to write import, and it's from Java. Java.util, and it's a string. And it's collectors. So I'm not sure why the IDE did not have it where I can click import and do it. But I will also go ahead and make room so we can see the whole thing. And it shows 2 lists. Maybe that's why, not sure. Okay, so now that we have this method, we can call it from the select menu page object by writing public void list string get all selected standard multi options. Now for the body, I'm going to let me see. I want to make it list string. Do not want to write void because void is not the return type. The return type is list string. Import from java.util. At this point, I'm going to call the method from the drop-down utility class, get all selected multi options, and pass in standard multi-select. And that's where I made a mistake. So let me go back here to this method in the drop-down utility and make sure to put in by locator. And I did put in by locator, but I did not call the right method from this class. So let me change this. Bingo. So it's showing me an error. Down utility class, we have it as public list string as the return type. But what I have not done is add static. So I can easily call it from the page object. The other ones have static. This did not have static. And now if I go back to the page object, it goes away. Yes, so that's all we need to create the method in the page object, and how easy it is to just call it. And like I mentioned before, we can use these methods in any class. So we do not have to repeat this information over and over. Now for the test, we write select menu page dot get all selected standard multi options. Then assign a value to list string with the name like actual selected options. Import list as a class, and let me put this on the next line. Yes. The assert will assert true. And for this, let's write actual selected options contains Volvo, which is the first selection. Copy and paste. The next one will contain, I think it was Opel. After Opel, it was it Audi? It was Saab. And then it was Audi, the fourth option. Yes, now that we are deselecting Saab, I must change assert true to assert false. Now, let's run. Bingo. We see the selections and we see it pass. To make this test fail, how about I change assert false to assert true for Saab? And we know it should fail because it was selected. I would also add a message for this here so we can just see what shows up. And on my projects, I always add a message, even though it's optional. Saab is selected as an option. It's not selected, but the assertion shows that it should be true, although it's actually false. And we see the message, sob is selected as an option. That would show up if it really was selected. Let me change this back to false. And just for, let me put this at the bottom. That's it for working with drop downs. Next, we'll work with dates. When it comes to the date field, we have the option of entering a date or selecting a date, depending on the application. On this application under test, you will see how the date picker page gives us the option of entering a date and selecting a date. We can perform both types of operations. So I will demo how to select a date, because entering a date is the same concept as typing information into any input element. The test script will load the application and land on this home page. On this home page, Selenium will click this widgets card. After clicking the widgets card, it will click this date picker menu item. When I click the select date field, we see the calendar. The calendar has a drop down for month and a drop down for year. Then it is a way to select any day in this calendar. Let's start by inspecting the date picker menu item. The parent has an element with the tag name of LI. ID value set to item-2. When I expand, we see the element we need, which is date picker with the span tag. Let's find the element by writing LI, square brackets. Within the square brackets, we write @ID equal to single quotes. Within the quotes, we write the value of ID, which is item-2. Bingo, we found the element, the parent element. And there are 5 elements on this page with that same value, matching 5 elements, 1 of 5. Even if I write /span, there are 5 elements, starting with radio buttons, but we need date picker. Inside the square brackets, write text, single quotes, and date picker is what we need. Now we see 1 of 1. Let me copy this value and go to the widgets page object to create our field and the transition method. The field name is date picker menu item. We found it by XPath and paste in the value. For the transition method, let's write public, and the page object name will be date picker menu page, and we click date picker. So that's the method name. First step is to scroll to the element, date picker menu item, click the date picker menu item, and return the new page object, date picker menu page. Now, to get rid of this red writing, let's create the page object by right-clicking widgets, new Java class, and the name of the class is date picker menu page, and it extends widgets page. Now that we have the date picker menu page created, we're going to go back to the AUT. and inspect the select date field. It has an ID value of date picker, month, year, input. Copy this value, but notice the tag name is input. This shows why we are allowed to enter a date into the field. Also, notice the date is located inside of the value attribute. We will use the value attribute to verify the date. In the page object, let's write private by select date field. We found it by ID. Paste in the value. The plan is to click the field and get the value from the field. So the method will be public void click select date. The body will call click from the base page, then pass in select date field from this class. Next method, we get the date by writing public string. Get date is the name of the method, and I would write for the get date method return. It returns a string, so that's why I wrote string as a return type. But it returned a string, but first we must find the select date field. And after we find the select date field, at this point is where we write the method to return the information. In previous tutorials, I used the getText method from Selenium to return information from the application. We use getText when there is value between the start and end tags. If I go back to the AUT, we see there is no value between the starting and end tags. Only thing we see as a value is the value attribute that has the date information. So that's why we will not use the getText method, because if I tried to use it, it would return no information. So to get the date, we must use getAttribute as the Selenium method to call. And what attribute do we need? We need the value attribute because it contains the date. The purpose of getAttribute is to return the value of any attribute. So in this DOM, we see value contains the date. But if I would have put ID as the value and not attribute, the Selenium method would return date picker month year input to the information we need. Okay, so we put value because that's the attribute we need. Next step is to inspect the date. And the date we're going to start with is month. Okay, we see it has a select tag and a class attribute of react-date-picker 2 underscores month-select. And it shows all the options when I expand select. January all the way down to December. Going to copy this value and find it by writing dot and paste in the value. Yes, with CSS, the dot is a shortcut for finding values that match the class attribute. The hashtag is a shortcut for finding values that match the ID attribute. Let me also inspect the year. It has a class attribute, but the difference between a month and a year is month shows month select at the end and year shows year select. So if I change month to year, it will find that element. Bingo. Okay, so in the IDE, let's create our field. Private by month drop down. We found it by class name. And I'm going to paste in the value. Let me just copy this here and do the same thing for year drop down to change month to year in both locations. Okay, now since the dot symbol is a shortcut for CSS, we can update the value from class name to CSS selector and also write a dot in front of React. And this would also find the year dropdown. So now that we have that information, we're going to create the methods in this class. And the methods would call the select methods from the utility class. Recall in one of our previous tutorials, we create this drop-down utility class to select by visible text, select by index, and select by value. Okay, I would make the date picker menu page call this select by visible text method from the drop-down utility class. So going back to this date picker menu page, let's create our method by writing public void select month and allow the test to pass an argument for this month parameter. Call the utility method. I could just write it, but let me just copy and paste it. I'm going to call it, then pass in the month drop-down locator and pass in the month parameter. Then import the static method. Month is complete. For the year, copy and paste and change it in all locations. Select year and also change the locator to year drop down. Okay, so now we have to make sure to create a method for the day. Let's go back to the AUT and select the day like August the 15th, 2024. Now, this here day also has a class attribute like the month and the year. However, this here has a div tag and not select tag. I'm going to copy this class value, but stop at the hyphens. This time, I would use XPath to find this element. Div, after the forward slashes, contains. I'm writing contains because I do not want to include the number day into this element right here. Contains at class and paste in the value. This point is where I make it detailed to select whatever day we pass in. I'm going to write the brackets. Within the brackets, I write text. Parenthesis equals. And within the quotes, I'm going to write the day. Since we are now located on the 15th day, I'm going to write a different day. And we see a highlight in the DOM. How about 2? Yes, 2 is highlighted in the DOM and in the UI. Now that we have this value and found the day, to find the day in our test script, we just make sure to change the 2 with the variable. So let me copy this value and go to our page object. And I will create a private method by writing private by day value, passing a string for the day parameter. Return by XPath and I paste in the value that we found in the DOM. Next, I will replace to with 2 double quotes and 2 plus symbols. Within the plus symbols, I pass in the day parameter. This would make it unique and flexible to handle any day we pass in from the test. Our test does not need access to this method. That's why I made it private, because it do not need to return anything using a by locator. It goes back to the quotes from Simon Stewart's where I mentioned if you have WebDriver APIs in your test methods, you're doing it wrong. The by locator is a Selenium WebDriver API. If I click by, we see it will show up in the Selenium package. So that's why I do not want the test to have access to this method that returns a by locator. Now, that's why it's private. But the next method will be public, because our test needs to click the day that we pass in. At this point, I'm going to call the private day value method. But after I click, because we're going to click the day that's passed in as the value. When it comes to the parameter, it's day. Okay, now here is a rule of thumb that I use when I implement this type of information on my projects. If I need the by value more than one time, then I create a private method. However, if I need the by value only one time, then I place the by XPath value in a public method. I do not create a private method. For example, recall in the working with table tutorial, I created a method to click the edit button. Let me go to the web tables page. This here method clicks the edit button, and I created this by information inside of the public method. I do it this way if I need the by XPath information, by ID, CSS selector, whatever it is I am returning for the by, I place it inside of the public method if I need it one time. You know what? I will show you a demo, because in this page, it would be a good idea to use it as a private method, because anything can happen as a test. For example, let's say we know there are months that have 31 days, not all months. But if there is a requirement to test which months have 31 days, then we can create a method to check if it is including 31 days in that month. August has 31 days. July has 31 days. But September only has 30 days. So a method that we can do for demonstration is go back to date picker menu page, and I will write public Boolean and name it is day in month. So we can check for any day in month, any day that we pass into the parameter. We must return it after we find the day value by passing in the day. Is it displayed? That's how we can check it. So this here is calling the day value more than one time from the private method. Most of the time, our project may need the by value more than one time. Therefore, it is best to create a private method and call that private method rather than creating that by value inside the public method. Although there are cases when you may need it only one time. Now, it also goes back to the page object model design pattern. and the drop principle. Don't repeat yourself. We do not need to repeat the same by XPath value statement more than one time by placing it in the click day method and the isDayEnMonth method. Let me demonstrate right quick by copying this by XPath. And what we could have done, and it will work, but it's not adhering to the drop principle. I could have done this here, by day value. And with this, I can comment out what we did, and I can put click day value that we passed in. The same way that I did for click edit. We could do that. And I can go back and do something similar in isDayEnMonth. And rather than saying click day value, I put return find day value is displayed. This will work. However, this is the downside when it comes to maintenance and the drop principle. Let's say, for instance, in the application, there is a change to this XPath value where now we must locate it without React. We have to change it in this method and in the other method. Click day and isDayEnMonth have the value, and the value must be changed in both methods. That's maintenance problem. And if there are more methods in this class that need it, there are more updates. However, with this one method that's called as a private, we make one change and it would take care of all methods that need that change. That's why I say if our class and application need this by value more than one time, it is best to write a private method and call that private method. Let me make sure to add back the React because I do not want the test to fail because of that statement. So now I'm going to make sure to call the day value private method for the test. I'm going to right click widgets in the test directory and the test package. Right click widgets, new Java class. The name of the class will be, how about I just make it as anything date test. Yes. Date test extends base test from port 3, 4. And to identify the test method, I write the test annotation, public void, and we name this here method test selecting date. Let me also make some room. And within this method, we create our reference named date picker page. And on the home page, we go to widgets, then click date picker. On the date picker page, we click select date. Next on the date picker page, we're going to select the month. We need to pass in the month. You know what? Let me create some variables. String month. And the month will be December. String day, let's make that the last day of the month in December. The year, let's make it 2034. Okay, so now we can pass in the month. After month, on the date picker page, select the year and pass in the year. And date picker page, we'll click the day and pass in the day. Now we are finished with the automation component. We need to test and verify if the date is correct. At this point, string actual date equals date picker page dot get date. And the string expected date has a format of 2 digits for the month, slash 2 digits for the day, slash and 4 digits for the year. Okay, so you know what? Let me go back to the AUT to verify. 2 digits for the month and 4 digits for the year. Month, day, year. Yes, 224. Okay, so we're going to call the month variable plus the / month and then a day / and now the year. Okay, last step is to verify if the actual date and expected date match. So for the assertion, I'll write assert.assert equals actual date, expected date. Also, let's add a message. And I'm going to put actual and expected dates do not match. Okay, and on my project, what I do for debugging purposes, and also just for report purposes, if there is an issue, I put something like actual date for a way to see what the actual date is that it returned from the application. And then I put what is expected. And I will put expected date. This is what we expect to return. Also, sometimes what I do is just to line them up so it shows the same date in the same column. Okay, so now let's run and see what the application returns. Now, it's going to be a failure, and I will tell you why it fails when we investigate. Yes, it failed. And look what happened. The actual date has 2 digits for the month, which is 12. But the expected date has December, which is spelled out. So let's create one more variable to match 12, which is December, the 12th month. The variable will be string month number equals 12. And I'm going to change the expected date to include month number. Now let's run, and it should pass. Yes, the test passed. We see it's green, and it shows 1 run and 1 pass. That's it for working with dates and part 3, working with WebElements. Next is part 4, Selenium interfaces and methods for unique situations. Welcome to part 4, Selenium interfaces and methods for unique situations. I will demonstrate some interfaces and methods that are required for automating an application using Selenium. In this part, you will learn how to take a screenshot and how to handle a modal. There is a difference between modals and alerts. So after modals, I will demo how to switch to a JavaScript alert. After switching to an alert, I will explain how to switch to a frame and how to switch to a window. Selenium is an API that executes very fast. Therefore, we will walk through how to dynamically wait for an element using dynamic wait statements. It is dynamic because the test script waits for a specified time or wait for a condition before executing the next statement. Last is Selenium interactions. I will simulate sending keys using the keyboard and making movements with the mouse. Next, we're going to investigate how to take a screenshot. When it comes to the screenshot, we will use the Take Screenshot interface. It is the super interface of WebElements. Therefore, we can use the driver or the HTML element to take the screenshot, then store the screenshot. I prefer to only take a screenshot when the test fails. Since the AUT is the same as part 3, then I will use the same base page and base test. So in our base test, let's add the after method annotation after the before method annotation from test.ng. The method name will be public void take failed result screenshot. Let me also make some room. For the parameters, it will be I test result. And we can name this here test result. The I test result is an interface from test.ng, even though it says import class. When I go to it, you will see how it shows interface, although the part for us to import show class. We see some integer variables and empty methods here. Our focus will be this failure result. Also this get status method. So in the base test, we need an if condition. So a screenshot is taken only when the test failed. If I test result dot. At this point, we see those int variables. I will select failure. Failure equals test result. Now we see some of those methods when I write dot, such as get status. I'm going to select get status. Now when it comes to the body, we are finished with the if condition, but inside the body, since take screenshot is an interface, we must typecast the interface so the driver can take a screenshot. Next is to assign the take screenshot with a reference like screenshot. Okay, so we have the object reference of screenshot dot to get the screenshot as. In this part, we're going to make this here be output type file. Now, the get screenshot as method performs the action of capturing the screenshot and storing the screenshot in a specified location. Since the target parameter is output type of file, then we store the screenshot in a file called source. Also, I'm going to import file. Source can be any name. Next, For the file is the destination. It is going to be a new file. Let's write the path name directory, which is system.get property. Add the double quotes and then write user.dir. Within this part, I'm going to skip a line so I don't write too much on the next part of the page. Editor. I'm going to write resources, and after resources, / before and after resources, then screenshots, another / and I'm going to also put the open parentheses and append it and go to the next line again. At this point, we have screenshots directory located in the resources directory. Let's go to the project and show you right quick where I'm going to put it. I'm going to move up and I'm going to right click and add new directory, resources. And within the resources directory, I'm going to right click new and add another directory. This one will be called screenshots. I believe that's the name that I put. It was a screenshot, yes, with an S. Okay, so now we have the location for the failed screenshots. Let me close this up. And now let's continue. For each screenshot, we're going to include the date before the file name. So now I'm going to write java.time local date dot now. Okay, and when I skip a line, I'm going to write, no, not the /, I'm going to write test result dot the method get name. And after get name, I'm going to append it to make the type as .png. Get name is a method from the iTest result interface that gets the name of our failed test strip. There is one more step to take a screenshot. We must make sure the file handler can make a copy, and it's going to copy from the source to the destination. Do you see how there is a red line under copy? We can add an exception, or we can add a try catch block. So I'm going to add a try catch block by selecting more actions and surround it with try catch. After the try catch, I'm going to write a print statement to show the file location. This is optional, but I like to have the location for documentation and a reference for when a test script failed, even though we know it's going to the screenshots directory. The print shot or the system.out.println would be screenshot located at plus the destination. That's all we need to add a screenshot of each test failure. Let's create a test and make it fail. So in the application, we're going to use this practice form page. We will attempt to click the submit button without scrolling to the bottom of the page. Inspect the button, and it has an ID value of submit within the button tag name. Okay, so since we know the ID is button, let's go to the practice form page object and create a field called private by submit button by ID, and the button name is submit. Bingo. Now the method will be called click submit button, and it will have a public access modifier, void as the return type. Click submit button is the name. Call click from the base page and pass in submit button, which is the field in this page. That's it for the page object. For the test, I'm going to the test package part 4, new Java class, and I'm going to create a package, and this package name will be called screenshots. Okay, now I'm going to right click the screenshot package, new Java class, to create our test. The test name will be something like capture failed screenshot test. And this test extends the base test. Okay, this time we import the base test from part 3, 4. And I'm going to add the test annotation from test.ng, which identifies the test method. The name of the test method will be public void. How about we name it test clicking submit button without JavaScriptExecutor, because that's what we use to scroll to an element. The reference will be practice form page, and on the home page we're going to forms, and we will, on the practice form page, we're going to click the submit button. Now at this part we have not added the practice form page. This is the practice form page, so I think we missed the step when it comes to clicking the practice form page. So let me see, is that here? Click, bingo. On the, now I'm going to click the submit button. Okay, so at this point the test will fail because we are not scrolling to the element like we have on other elements like this here. If I wrote this here, it'll pass, but we're going to comment this out to make sure it failed. Now let's run. It never did scroll, and it failed. Element click intercepted exception. If I scroll to the bottom of this here, yes, scroll to the bottom, and it shows screenshot located at, and it gave us the path that has these screenshots. And I did not close up the date. But know what? We have the screenshot. And before going to the screenshot, let me just go here and close up this part for the, I'll come back to that and do it later. Screenshot, and here is the screenshot. And it shows that we never did scroll to the bottom of the page. So in our projects, That's how I implement this here part to capture a screenshot, because it's good for debugging, especially when I'm executing many test scripts at the same time in parallel, or just execute many test scripts. So when it failed, I can go to it and see why it failed. It shows the date, the testng.png, and that's it for how to take a screenshot using testng and Selenium. Next, I will show you how to handle a modal. A modal dialog is a pop-up that allows interaction without switching to the element from the home page. In this AUT, we go to Alerts, Frame and Windows card. Scroll down to select Modal Dialogs menu item. At this point, there are two buttons, Small Modal and Large Modal. Both pop-ups have information with the close button and an X in the top right corner. For our test script, let's click the Small Modal dialog button. Get the text in this pop-up, then verify the text is, this is a small modal, it has very less content. Then click the close button at the end of our Selenium test script. Start by going back to the home page. Inspect the card. In the card, we see it has an H5 tag name with an ID value for the parent tag of app. To find it, let's write 2 / div, and within the div tag, we write @ID equals 2 single quotes. Within the quotes, we write app. Now we write 2 / H5. Text, parenthesis. You know what? I'm going to make sure that it contains the value because the word is pretty long. Text, parenthesis, comma. And let's put alerts as the value and press enter. I'm going to copy this value, then go back to the IDE, to the home page object. The field will be private by alerts. How about I go ahead and just name it alerts frame Windows card. By XPath is how we found the value and paste in the value. Now for the method, it will be a transition method, a public transition method, public, and the name of the page object will be alerts underscore frames underscore, then I put Windows page. The method name will be go to alerts frames Windows card. It's long, but it's detailed and descriptive. The first step is to scroll to the element alerts frame Windows card. After scrolling, we click. Now we write return new for the transition. I'm going to copy and paste the name of the page object. At this point, let's go ahead and create the page object. But first, we must create the package by right-clicking demoqa.pages. New package. The name of the package will be alerts underscore frames underscore Windows. Now we create the page object by right-clicking the sub package, new Java class, and now we paste in the page object. The page object extends the home page. Bingo. Now we see two related problems. That's because we must import the page object. Now, related problems goes away. After clicking the card, we transition to this page where we must click the Modal Dialogs menu item, inspect, and we see the parent tag has an ID value of item 4. Expand it, and now we see the span tag for the menu item that we need, Modal Dialog. To find it, let's write 2 forward slashes, and then I'm going to write LI square brackets at ID and item 4 will be the value. Now span tag and the text of the value, which is Modal Dialogs. Bingo. Now that I have the value, let's go to the home page and create the field. Private by. The name will be Modal Dialogs menu item. We found it by XPath. Paste in the value. Now, the page changes when clicking the Modal Dialog menu item. So I will create another transition method. Public Modal Dialogs page. The name is click Modal Dialogs. The first step is to scroll to the element using JavaScript. Modal Dialogs menu item. Next is to click the Modal Dialogs menu item. Then return new Modal Dialogs page. At this point, I will import the static method, scroll to element.js, then create the page object. I'm going to create the page object by right-clicking the sub-package, alerts, frames, and windows, new Java class. Now, I paste in the value of Modal Dialogs page, and it extends the alerts, frame, and windows page. There are 3 elements on this page that we need to inspect. We need to inspect the small modal dialog button, text inside of the pop-up, and this close button. Let's start by inspecting the button, small modal. When I inspect, we see it has an ID value of show small modal. To confirm it is a unique value, let's write hashtag, which is the shortcut for CSS, then paste in the value. And yes, we found the element. To confirm, if I write any kind of another letter, we see red. So yes, this is a unique value. Now I'm going to go to the page object and create a field. Private by small modal button. We found it by ID. Paste in the value. Now we are finished with the field. Other 2 fields are private by small modal text and close button. Let's go back to the AUT, and I'm going to inspect the text. After inspecting the text, we see it does not have an ID attribute. So let's find the text using the text XPath function and the contains XPath function. It's located in a div tag. So I'm going to start with the 2 forward slashes div. Within the brackets, write contains text, parenthesis, comma, 2 single quotes. And the text contains small modal. So I will write small modal, then press enter. Yes, found the value. When I copy it, I'm going back to the IDE. Then write by XPath. Then paste in the value. Next, let's inspect the button. The button has an ID value of close small modal. I'm going to copy that value and let's verify if we can find it and it is unique. Hashtag close small modal, and yes, we found the item. So now I go back to the IDE equals by ID. Paste in the value. At this point, we are finished with the fields. Now let's create the methods so we can perform actions on the fields. Let's start with public void click small modal button. Called click, then we click the small modal button. Next is public string get small modal text. We're going to return the value after finding the small modal text. The method we need is get text. We need that method because it has values between the start and end the tag. Let me go back and show you right quick. Because in the previous tutorial, we did not use get text, we used get attributes. But let me show you one more time, even though we have used get text before. When I highlight the element, we see text between this tag, div, starting tag, and ending tag. This here is the value we see. This is a small modal. It has very less content. For this type of information from the application, we use get text. Going back to the IDE, we have one more method to create, and that is to click the close button by writing public void click close button. Now we call the click method close button. At this point, we are ready to create our test. Therefore, let me go to the project, scroll down to part 4, screenshot package, right click, new package, and I will create a package for modals. Right click the modals package. Let me refactor this here. Let me delete it. And I'm going to start over, and I need to create the package but replace screenshot with modals. There it is. Now the sub package under part 4 and not a package under screenshot. Right click modals, new Java class. The class will be called modal test, and it extends base test from part 3, 4. For the test, we write the test annotation from test.ng, public, void, test modal dialog. And we're going to continue with writing the reference var. How about we name it AFW page? On the home page, we go to alerts frame Windows card. I'll do this a little different because we can click the modal dialog, but for this, let me show you another way. Now, we're on the AFW page. We're going to click the click modal dialog menu item from this here and assign this to another reference. And let's name this modal dialogs page. Either way is okay to write it. Now on the modal dialogs page, we're going to click the small modal button. Now our code will get the text with modal dialogs page dot get small modal text. And this method returns a string, and we will name it actual text. Now, the actual text will contain, but let's go ahead and put that in the assert true statement. By write assert dot true. Actual text contains, what does it contain? Small modal. Let's go ahead and create a message. I like to create messages just in case if a test failed, we know why it failed. The message does not contain small modal. The last step on the modal dialogs page, remember it is to close. So let's click the close button. At this point, let's run. The test passed without an error. That's it for how to handle a modal. Next, we're going to switch to a JavaScript alert. The purpose of an alert is to show a message. With that message, the application requires an action from the user, such as clicking a button. There are 3 types of alerts. We have information alert, confirmation alert, and prompt alert. For the test, we will go to the AUT under the alerts frame and Windows card. In that card, we click alerts menu item. And on this page, we see 4 buttons. The first 2 buttons are information alert that will be triggered when we click the button. It shows a message that says you clicked a button. It also has an OK button. At this point, we cannot perform any kind of action on the main page. Modals and alerts look the same, but they are different. The modal allowed us to inspect the dialog by getting the text and clicking the button. For an alert, we are not allowed to inspect the message or click the button. Right now, I am right-clicking the mouse and nothing is happening in the dialog or on the main page. We are not allowed to inspect because the alert is not attached to the DOM. So when it comes to Selenium, it provides a special method for switching to this alert. After switching to the alert, Then we can perform an action on the alert. Therefore, our test must switch to the alert, perform an action, then go back to the main page. We are going to write a test to click each type of alert. Let's start with the information alert. The first test, let's go to the, we'll click the information alert button. Verify this message, then we'll click the OK button. Let's inspect the alerts menu. And we see it has an ID tag, LI tag, ID attributes with item 1 as the value. Expand, and it has span as the tag name. So to find that element, let's write 2/, the tag name LI, square brackets, at ID equal to item 1. Now, / to traverse the DOM, span, text, parenthesis equals alerts. And we found the element. Now copy the value and go back to the IDE. To create the field, let's write private by alerts menu item. We found it by XPath. Paste in the value. Now for the method, I will write public name alerts page. Click alerts. The first step is scroll to the element, alerts menu item. Then click the alerts menu item. Next is to return to the alerts page. And we're going to create an alerts page object by going to the project, right-clicking the alerts frame windows package, new Java class. The name of the page object is alerts page, and it extends alerts frame and windows page. Now that we have the page object created, let's go ahead and create a test by right-clicking part 4 package in the test directory. New package. The package name will be alerts. Right-click alerts and now create the test class, which is alerts test. Bingo. And it extends base test from port 3_4. For the test method, it will be public void and it will be called test information alert. From the home page, we go to alerts frame windows card, then click alerts. When clicking alerts, the page transitions to the alerts page. On the alerts page, the next step is to click the information alert button. So let's inspect, and it shows an ID value of alert button. So let me copy that value and go to the page object. In the page object, we write private by, and the name will be information alert button. We found it by ID. And paste in the value. Let me import the bot class. Next is to click the button. So the method is public void click information alert button. Call click from the base page, then pass in information alert button. The previous step transitioned to the alert message. So now that's why we click the information alert button. At this point, let's get the alert text message. Recall, we're not able to inspect the alert by right-clicking the alert. Therefore, we must use that special switch to method from Selenium to get the text and click the OK button. The message shows you click the button. So now, the plan is to create this course to resemble my projects that I do on my job. Therefore, let's create a utility class for switch to by going to the project, right-clicking utilities, new Java class. Name is switch to utility, and it extends utility. Let me bring this public class to the next line. Next step is to create a private method that is static, and it returns WebDriver.targetLocator. The name of the method is switch to. Now that we have this part, we should return driver.switch2. This here has a return type of WebDriver.targetLocator because switch2 returns the target locator interface. The target locator interface is within the WebDriver interface. If I go up to the top, we see WebDriver is an interface. So in the switch to utility class, this method is private. And we do not have to write this driver.switch2 statement over and over in this class. For example, when I create the next method, it will not be private, but it will be public. And this public access modifier will allow our test to access this class. Up to this point, in the previous tutorials, I would call utility methods from the page object, but this time I would call the utility method from the test class. So we need to get the text and accept the alert by clicking OK. So let's write public static void get alert text. And I apologize, this will be public static string. So by it being string, I'm going to make sure that it inserts, that we insert string right here. Now let me get rid of this function to insert. And the name is get alert text. We can bypass writing driver.to switch to over and over. All we need to do is call this switch to method. And it looks good for readability. Now that I have called the switch to method that is private, our test script allows our to switch to an alert. After switching to the alert, then we get the text. Get text is different from the get text from the WebElement class. This get text is part of the alert interface and not the WebElement interface. and we see it returns a string. The other methods, dismiss, accept, and send keys, are all part of the alert interface, but they return void. In the test, we are going to call this getAlertText method because it will return the text from the alert. Let's go to the alert test. And we know that the message that we expect will be string expected alert text. And the name was you click a button. That was the phrase. Now, at this point, let's verify the alert text by writing assert equals. And we need to check if the actual and expected text are equal to each other. For the actual text, we call the utility method getAlertText. And we're going to compare it to the expected alert text. Let me import this method and change this so we can call any method from that switch to utility class. Now, let's go ahead and write our customize message. The customize message will say actual and expected messages do not match. Now, for clicking the OK button, we must accept the alert. Therefore, in the switch to utility class, we create an alert method, public static void. The name will be accept alert. We always switch to, so our code switches to the alert. And when it switches to the alert, we will accept the alert. The purpose of accept is designed to automatically click the OK button. So in the test, after the assertion, let's write accept alert. Now, let's run. On the alerts page, I forgot to write the step to click the information alert button. That's my bad, I apologize. So now, let's run. Bingo, the test passed. Now, I do want to make this point that if we want to perform an action after the alert, we must make sure to accept the alert. Because if I comment out, accept alert, and try to perform an action like clicking the information alert button again, watch what happens when we try to click this button and not accept the alert button, click the OK button on the alert. It's going to return an exception because we did not handle the alert. Bingo, it failed, and it shows unhandled alert exception. Unexpected, alert open, alert text, you click the button. So we must make sure if you have a project and you need to perform an action after the alert, make sure to accept the alert. So now when I run again, the test will pass and it will bring up the alert again because I'm clicking the information alert we see it shows up and it closed. So I just want to make that point because you do not want to come across an exception. So let me remove that statement because we're not clicking the information alert button after accepting the alert. That's it for information alerts. Next is the confirmation alert. For the confirmation alert, we will use the same page. And we see the third button is the confirmation alert button because it says on button click, confirm will appear. When I click the button, it shows two buttons, OK and cancel. We will click the cancel button for this test. After clicking the cancel button, then the test script will confirm this here result shows up. You selected cancel. Let's start by inspecting the button. We see it has an ID value of confirm button. Let's also inspect the result. And it has an ID value of confirm result. In the IDE on the alerts page object, let's create a field for the button and the result. Private by confirmation alert button. We found it by ID and the value was confirm button. Next is the message, and that is confirmation result. We found it by ID. The value was confirm result. Now we create both methods. At public void click confirmation alert button. Make room. Call click from the base page, click confirmation alert button. Let me make sure. Bingo. This button is called confirmation alert button. And I see an error because it looks like it's trying to call a method that takes care of the error. Now we have to get the confirmation result. That method is public and the return type is string. Let's name it get confirmation result. It would return the value after it find the confirmation result. Then get the text. At this point, we can go ahead to the test class. For the test class, I would have changed the test annotation from identifying the test method at the method level, and I'm going to switch it to the class level. That way, every method in this class will be identified as a test method. The method name will be public void test confirmation alert. The first one was information alert. The second one, test confirmation alert. Let me minimize this and go on to the second method. From the home page, we go to alerts, frame Windows card, then click alerts. The AUT transitions to the alerts page. There are 3 more steps. Our code must click the confirmation alert button, click the cancel button, then get the result. Therefore, on the alerts page, next step is to click confirmation alert button. We have not created a method for clicking the cancel button, but let's go ahead and write the step. And that is to dismiss the alert. Now, we know it's red because the method has not been created, but we'll take care of that after we take care of the next step, which is to get the confirmation result. Let's create a method, a string for actual confirmation result equals to, let's say we want to call the method for canceling the button. No, I'm gonna keep it like this here. Now, Selenium provide a method for getting the confirmation, but we're going to, on the alerts page, get confirmation result. Selenium provides the dismiss method for clicking the cancel. At this point, let's go ahead and create that method for dismissing the alert in the switch to utility class. The method will be public static void dismiss alert. Always switch to the alert, then perform an action, and this will be dismiss. Now, we have the dismiss alert method. When we go to the test class, it should change from red to white. Yes, this is the part I was considering what should I do next. Now, I'm going to create a variable for the expected confirmation result. And the confirmation result message says you selected cancel. And we can add this at the top of the method. We can also add it at the bottom right here along with the actual confirmation. Either way is okay. Now, let's compare the values expected and the actual by writing assert equals passing the actual confirmation result, then the expected confirmation result. Next, I'm going to write a customized message that says you did not select cancel. Now, let's run. Yes, it passed. That's it for the confirmation alert. Next is the prompt alert. The prompt alert is different than the information alert and confirmation alert because it allows us to enter data into the alert. On the AUT, let's go to the page for alerts. And this time I would click the 4th button, but look what the message says. On button click, prompt box will appear. So when I click the button, it shows a message, please enter your name. And the field to enter the name. Also an OK button and a cancel button. Our tests will enter some kind of name like Joe Doe. Then click the OK button. Next, the test script will verify this message says you entered Joe Doe. Let's start by inspecting the 4th click me button. And it has an ID value that says prompt button. But notice the prompt is misspelled. Let me find it. Yes, we found it in the DOM, but the P is missing from the ID value prompt. So now I'm going to go back to the IDE and we will create a field for clicking that button. The field is private by a name such as prompt alert button. We found it by ID. The value is prompt button without the P. Next is the method. Public void click prompt alert button. Call click from the base page and pass in prompt alert button. At this point, we can go back to the test. Let me copy this first line because it will be the same thing in the next test. The name will be test prompt alert and paste in that value. Now we are on the alerts page, and on the alerts page we can click the prompt alert button. Selenium provides another method for typing data into an alert, and that's the send keys method. So the next step is to enter that name after clicking the button. But let's go to the switch to utility class and create that method by writing public static void set alert text. Pass in a parameter of text and it will switch to the alert. After switching to the alert, it's going to send keys and pass in the value of text. Now go back to the alert test so we can set the value on the alerts page. After clicking the prompt alert button, I'm going to call set alert text from the utility class. And after setting alert on a utility class, at the top of this method, let's create a string alert text. How about we pass in a value like Selenium with Java? And we're going to pass in that variable. Bingo. So now we have set the value in the alert. The next step is to click the OK button by writing accept alert. Now we have entered the value, clicked OK. The last step is to get the result. And the result, I need to inspect. And it has an ID value of prompt result. Let's find it just to make sure it's unique. Yes, so now let's go to the alerts page and create the field and the message. And the method, not the message. So private by prompt result. Found it by ID, paste in the value. Now for the method, it's public string get prompt alert result. And we're going to return the value after finding the prompt result with get text. So for the test, it returns a string that will be assigned to actual result. Now we call the method from the alerts page to get the prompt alert result. To verify, we write assert equals, and we will pass in the actual result. Now, we do not have a variable for expected result. So let me write expected result, and I will come back and create a value for that. But let's write a customized message that says actual and expected results do not match. Now, for the expected result, sometimes people hard code the value right here, such as you entered and pass in this variable. Sometimes people do that. And either way, it's really okay. But most of the times, I create a variable and place it at the top, or I place it right after the actual result. So right now, I'm going to write string expected result. And then here we go. Now let's run. And it should work because the actual and expected should match. But let's see. Yes, the run window shows a green check mark, one run, and it passed. That's it for switching to alerts and also prompt alerts. Next, we will switch to frames. The purpose of an iframe is to embed a document within the current HTML document. For example, this page on the AUT, it has two boxes, a big box and a small box. Both are iframes. Sometimes a clue to let us know if the page has an iframe is to right-click the box, and we see this frame. This frame is an indicator that this is an iframe. It's the same in another browser such as Chrome. If I go to Chrome and right click, we see this shows view frame source. That lets us know that it's an iframe. Also, it shows reload frame. Let me go back to Firefox browser. And under Firefox browser, I'm going to inspect the iframe. And when I inspect, we see this element has an HTML tag. This HTML tag is a child to the iframe tag. When I scroll up the DOM to the top, we see the iframe tag is embedded inside of the root HTML element tag. That explains how the iframe tag is inserted within the current HTML document. Now, when it comes to the tutorial, this tutorial will cover 3 ways to switch to a frame. The 3 ways are string, index, and WebElement. There will be 2 test scripts that we will cover. The first test script consists of getting the text. This is a sample page inside of this big box, and getting the header frames. Second test will get the text inside of this small box and get the header. Now, there are different ways to doing each part. One of them will use a different overloaded frame method. let's begin by inspecting this frames menu item. It is located inside of the li tag, and it has an ID value of item -2. We see the span tag. Let me locate this element with li at ID, and we write item -2 as the value. Now we find the menu item frame by span, and within the span tag, we write equal to frames. Yes, found the value in the IDE. Let's go to the alerts frame windows page object. And within this page object, let's create a field. Private by frames menu item. We found it by XPath. Paste in the value. The method is public frames page with the name of click frames. At this point, we're going to scroll to the element frames menu item, then click frames menu item. Last statement will return new frames page. Let's go ahead and create the page object. We have our package, alerts frames windows. Right click the package, new Java class, name frames page, and it extends the alerts frames windows page. Although we have not added any fields and methods to this page object, we can start our test by clicking the frames menu. So let's create a package. In the test directory, I'm going to right click part 4, new package, and the package name is frames. Now I right click frames package, new Java class, and this time I'm going to name the class, and that's frames test. Frames test extends base test from part 3, 4. Okay, so now within this class, I write the test annotation, public void test frames big box. And let me make some room. Now we have the test method, and within this test method, I'm going to write homes page, and we go to alerts frames windows card, then click frames. Bingo. And the test will be on the frames page. The next step is to get the text inside of this big box, which is an iframe. This is a sample page. Let's inspect it. And it has an ID value of sample heading. Let's find it. We'll now write hashtag sample heading. We found the elements. So now in the page object, let's create the field. Private by, and let's write a name like text in frame. Found it by ID. And the ID is sample heading. Now, at this point, let's go ahead and create the method. Public void get text in big frame. And I'm going to find the text in the frame, then get the text in the frame. The get text method returns a string, and let's assign it to big frame text. Let's write a print statement. And it's going to say big frame text. And let's call the variable big frame text. Now we're going to return big frame text. Okay, so now for the test, and we should see a compiler error because it should be public string, because we are returning a string for big frame text. For the test, let's continue after clicking frames. And with that part, I'm going to write frames page get text in big frame, then assign it to actual big box text. The string expected big box text is, this is a sample page. So with this, we have the actual and expected values. So I can go ahead and write the assertion. Assert equals actual big text, expected big box text. And with the message that says actual and expected text do not match. Let's go ahead and run. Now this test will fail due to a no such element exception. It will not be able to locate an element. Yes, no such element exception. Now, when we look at the application, let me go back to the console to show you what it could not locate. It was unable to locate the element. Which element? The sample heading element. That is the element inside of the frames page, text in frame. Now, let me go to the application. The test script failed because it did not switch to the iframe before getting the text. Let's inspect the text one more time. We saw a no such element exception because the test could not find the ID value sample heading. Scroll up the DOM and we see the iframe tag. Recall, from the introduction, there are 3 ways to switch to an iframe: string, index, and WebElement. Let's see how to switch to an iframe using a string. To switch to an iframe using string, the DOM must have an ID attribute or name attribute. In the AUT, this iframe has an ID attribute with the value of frame 1. So in the page object, our field will be private string and not private by. How about a name like iframe big box. The value is frame 1. For the method, let's also make it private. This method is private because someone using the application has no idea this is an iframe. Therefore, our test should not be concerned about switching to the iframe. The private access modifier prevents our test from calling the method. Void switch to big box. Driver dot switch to frame. Do you see the overloaded method in this IntelliSense? We see frame int index, frame string name or ID, frame web element, frame element. Notice string name or ID is the overloaded method, and we're going to use this one to pass in the string. iframe big box. Inside of the get text in big frame method, as the first statement, let's call the switch to big box method that we just made as private. Now our test will switch from the HTML main pages DOM to the iframe before getting the text. Now let's run. Yes, it passed. For the second part of this test, let's get the header, which is frames. Inspect it, and it has an H1 tag, but it does not have an ID attribute for the H1 tag. But if I scroll up, the ancestor has a div tag with an ID attribute set to app. So we're going to find the header by writing div square brackets at ID equals app. Now let's traverse the DOM by writing H1, which is the tag name. Square brackets text equal frames. Yes, and we found the element is highlighted. Therefore, let's go ahead to the page object and create a field. The name will be private by header frames text. We found it by XPath. Let me paste in the value. Let me go back and copy this value and paste it. Yes. Now, for the method, I will write public string get header frames text. For the body, it will return the value after finding the header frames text using the get text method from Selenium. Last step on this frames page header text, we're going to assign it after getting the header frames text. Assign it to string actual header text. Yes, and the string expected header text is assigned the value of frames. Now let's write assert dot assert equals, and we will pass in the values of actual header text and expected header text. For the message, how about we write actual and expected header text do not match. Now let's run. And it should fail, but let's see. I'm expecting a no such element exception. Yes, no such element exception. What does the show us? No such element, unable to locate element. Which element? The frames, which had the H1 tag. That's the header. But know what? Let's see something right quick. The console, it shows big frame text. This is a sample page. So we know it was inside of the frame. That's our frame. However, we still see this no such element exception. The test script did not locate the header because it did not switch out of the iframe back to the main page's DOM. Selenium has two methods that allows us to switch from the iframe DOM to the page DOM. The two methods are parent frame and default content. Let's go to the application. Parent frame switches control from the current frame to the parent of the current frame. If the parent frame is an iframe, then control switches to the iframe. If the parent frame is the main web page, then control switches to the main web page. The default content method switches control from the current frame back to the main web page. It does not matter if the current frame is a child to another iframe or a child to the main web page. Let's inspect this sample web page. Okay, now inside of this big box, in the DOM, check out the breadcrumb. We see iframe right here. But if we go back, we do not see another iframe. There is no other iframe. Before the HTML root element, that shows the parent frame is the main web page. If I write 2// frame, then cycle through the elements, we see the breadcrumb. Yes. So this here iframe shows another iframe before the HTML root element. So we see iframe right here. If I keep going back, we see there is another iframe. This means an iframe is embedded within another iframe. However, for our scenario, we can use the parent frame or we can use the default content method. Let me show you. Go back to the page object. Frames page. When dealing with frames, it is best to switch to the frame, then switch out of the frame in the same method that is performing an action, because we have no idea what action the next method will perform. Therefore, after printing this printout, big frame text, we're going to write driver dot switch to parent frame. Parent frame. Now our method will get the header. Let's run. It passed. We see the green check mark. Okay, so we see that parent frame worked. Watch what happens when I change it from parent frame to default content and run again. It passed. Although we can use parent frame or default content, most of the time we implement the default content method because it always goes back to the main page. Let's add the switch to frame methods to the utility class, because we have implemented it right here and we also implemented it right here. So let me go to the switch to utility class, because I mentioned more than one time the plan is to make this course resemble projects that I work on in my job and what I consult for. So I'm going to create a public static void method called switch to frame string, and we pass in string value. Switch to dot, and this time we will switch to a frame and pass in the value. The next method will be public static void switch to default content. There would not be a parameter, but we are going to call the switch to method in this class frame default default content. That's all we need. So now let's go back to the page object and replace these methods. So for the switch to big box, we're going to write switch to and call switch to, it was called switch to frame string, and then pass in our frame big box. Import the method, yes, and I'm going to make this here where we can call any method in that class. So this here, line 19 and line 18 perform the same action. So let me comment out. And for the switch to default content, it's called switch to default content. And that's all we need. And you know what? Rather than making these comments, I'm going to delete it. Now, let's run again to confirm the test pass after calling the methods from the switch to utility class. Yes, it passed. So now we are finished switching to a frame using a string. Next, let's switch to a frame using an index. We can switch to in our frame using the position as the index. In the DOM, you will see how / iframe shows all of the iframe elements and strings. We see there are 23 elements that match this value. Some of those could be strings. This time, let's find the small box iframe. When I cycle through these elements, we're looking for the second iframe, which is the small box. We see frame 1, that's the big box. Frame 2, that is the small box, and it is 4 of 23. If I go down to the small box, we see how it's highlighted. Okay, so it is the 4th position, and that's the one we need. The integer index position is based on 0. Therefore, position 4 is the same as index 3. Let's also inspect and find the small box text. It has an ID value of sample heading. It is the same as ID value in the big box. There is no need to create a separate field for small box text because we have text in frame to satisfy the big box and the small box. Let's write our method for switching to the small box. Now for this here, I would also make it private, like the switch to big box, by writing private void switch to small box. Before the details in this method, let's go to the switch to utility class for the index position method. And I will create that method by writing public static void switch to frame index, passing an integer index as the parameter. Switch to dot frame and pass in index. Now let's call this method from the page object. Go back to the frames page and write switch to frame index, then pass in 3. This is how we switch to a frame using index. Now, let's create our method for getting the small box text. We create that by writing public, make more room, public string get text in small frame. First step is to switch to the small box. Next is string small frame text, and we find text in frame, then get text method from Selenium. Let's also add a print statement. Small frame text, and that's the small frame text. At this point, we switch out of the iframe to the main page by writing switch to default content, then return small frame text. That's it for the page object. Now, let's create our test. And our test, we see we have the test annotation, and in the last tutorial, I put the text annotation at the top so it relates to the test class. You know what? I'm going to keep it at the method level just to show you different ways of doing the same thing. So for this here, the next test will be at the method level, and that name will be public void test frames small box. This test is similar to the previous big box text. I could copy and paste the same code, but let me walk through it real fast. From the home page, we go into the Alert Frames window card, then click Frames. After clicking Frames, it's going to take us to the Frames page. Now that we're on the Frames page, we are going to get text in small frame, and that's a string. So we assign it to a string, actual small box text. The string expected small box text is, this is a sample page. Now we assert the values to check and see if the assert is going to return a true value or same matching value for actual small box text and expected small box text. Let me go ahead and add a message just in case an error shows up. Actual and expected text do not match. Okay, so next is the string actual header text, and that comes from the Frames page. Get header frames text. Bingo. Now we have the expected header text, and that's frames because that's the header name. And I also write assert equals actual header text, expected header text. And this here would be the customized message, actual and expected text, header text do not match. Now let's run. Bingo, the test passed. We see the green check mark, one pass, one run. That's it for switching to a frame using index. Next, I will show you how to switch to a frame using WebElement. When it comes to the WebElement, if the ID attribute or the name attribute is not available in the DOM, then I prefer to use WebElement. In the AUT, we will look at the DOM, and you will see how the DOM shows frame 2 when I inspect the iframe as an ID value, frame 2. But let's find the element without frame 2. The parent is div tag with frame 2 wrapper as the ID value. We write 2/div at ID equals 2 single quotes. And let me just copy and paste this value. Bingo. Now, 1/iframe, and we found the element. This is a longer way, but it still will work. I'm going to copy the value, then go to the frames page object. And in this frames page object, I will create a field. Private by, and how about iframe small box, and we found it by XPath. Paste in the value, then add the semicolon. In the switch to small box method, I will comment out the switch to frame index method that we called from the switch to utility class. And when I comment out, I will create a method in the switch to utility class. And that method will be public static void switch to frame element. The parameter will be WebElement element. Now, I need to import WebElement. Inside of the body, switch to frame, and I will pass in element. Bingo, that's it. Now I will call this method by going back to the frames page, and since it is a web element, switch to frame element, we must first find it since it's a web element, then pass in iframe small box and add the semicolon. Now let's go back to the test and look at the code, then run again. And it should pass again. Bingo, yes. Test frames small box passed. That's it for switching to frames using WebElement. We are finished with switching to an iframe using string, index, and WebElement. Next, we will switch to Windows. Some applications open a new browser window or an extra tab after performing an action. Selenium treats the extra tab just like a new window. In this tutorial, I will discuss 3 types of window methods. The 3 methods are getWindowHandle, getWindowHandles, and switch to window. The getWindowHandle method gets the current window handled, and the getWindowHandles method get all the window handles. Window handle is unique, and it is an alphanumeric ID assigned to each window. We use that unique ID for the 3rd method, switch to window. The switch to window method switches focus between the windows. Our AUT would be this browser window page. It has 3 buttons: new tab, new window, and new window message. The same concept works for all 3 buttons. So let's walk through the scenario for new window. We click the button, switch to this new window, then verify the URL. Let's start by inspecting the browser windows menu item. When I expand this window to make it bigger, we see the LI tag has an ID value of item-0. And the element we need is the span tag that has browser window as the text. So let's find the element by writing 2 / li at ID equal to item-0. Span, and we will make this detailed by writing text parenthesis single quotes, then write browser windows. Bingo. We found the element. So let me copy this XPath value, go to the page object alerts frame windows page, and create the field called window, how about browser, Windows, menu item. We found it by XPath. Paste in the value. Next is the method, and the method will be public with the name set to browser Windows page, and that would be the name of the page object. The name of the method would be click browser Windows. Now, the first step is to scroll to the browser window menu item. Then we click the browser window menu item. Last statement is to return the browser windows page. Let's go ahead and create the page object within this alerts frames windows package, new Java class. And the name is, let me do it one more time. New Java class, then paste the name of the page object, browser windows page. Extends alerts frame windows page. Okay, so now that we have created the page object, we can go ahead and create our test to at least click the browser window menu. Let's scroll down to part 4 in the test package. Part 4, right click, new package. The name of the package will be Windows. Right click Windows, new Java class. The name of the class will be Windows Test. And it extends base test from part 3, 4. Now, for our test, we begin with the test annotation with the method name of test new window. How about URL? Now, we at the port where we can go to the Windows page. After we come from the home page, go to alerts frame Windows card, then click browser windows. The next step after clicking browser windows is to click the new window button. Let's inspect the new window button, and it has an ID value of window button. Let's make sure it is unique and it's highlighted in the DOM. It remains highlighted. So at this point, let's create the field in the browser windows page object by writing private by new window button. We found it by ID. Paste in the value. Next is the method, and the method will be public void click new window button. Call click from the base page, new window button. On the Windows page, for our test, we click new window. Yes. So after clicking the new window button, we must switch to the window. Now, let's write the logic for the page object for switching to this new window. Go back to the page object and make sure to make room. We begin by writing the method with public void switch to new window. We will perform 3 steps for switching to a new window. Step 1 is get the current main window handle. Step 2 is to get all window handles. And for step 3, that's when we switch to the new window using the window handle. Okay, so for step 1, we get the current handle by writing driver.getWindowHandler without an S. Recall, the window handle ID is alphanumeric, so that means the ID is a string. Let's name it current handle. For this tutorial, I will add a print statement that says main window ID current handle. Let's also insert a new line. Now, we are finished with step 1. For step 2, we get all of the window handles by writing driver.getWindowHandlers with an S. This method returns a set of window handles, which can be used to iterate over all open windows. Therefore, we assign it to a set string. Since it returns all window handles, let's name it all handles. Yes, also import set. Include a print statement that says number of open windows. Then we call all handles. Dot size is a Java method. The size method returns the number of window elements. Before switching to the new window, we must first loop through both windows. Let's use an enhanced for loop by writing string handle, all handles. Let me move this up some. Yes, now if the current handle equals handle, then add this print statement that says first window ID handle. Yes, now the else statement would be driver.switch to. So if the current handle does not equal the handle, then we switch to the window and pass in the handle. Also include a print statement. This print statement will say second window ID handle. Since the driver.switch2 window is a switch2 method, let's add it to the switch2 utility class. So let me go to the utilities package, then select switch2 utility. This method will be public static void. And the name of the method, let's make it switch to window. Also, we're going to pass in a parameter that's a string named handler. Now that we have that, we call the switch2 private method in this class. Switch to the window, then pass in handler. Okay, so now we call this method switch to window from the browser windows page object. Now, what I will show you is call a method and pass in handle. That's it. And when it comes to readability, it's easier to read switch to window than driver.switch2.window pass in handle. Both ways will work. It really does not matter. I just like to be organized with my project. Let me import the static method and remove the driver.switch2 method. If you're in your project, you might add driver.getWindowHandles to a class utility and driver.getWindowHandle to a utility class. Both are methods in the WebDriver interface. If I go to getWindowHandle, we see it returns a string, and getWindowHandles returns a set string in this interface WebDriver, because we see I next to WebDriver. If I go up to the top, we see it's the interface WebDriver where those methods are located. You know what? Let's go ahead and add those methods to a utility class. So let me go to the project and go to utilities. Right click, new Java class. The name of the class will be get utility. And get utility extends utility. Now, those methods will be added to this class, and we can call it from any class that's a page object. Public, static, void. Now, this really should be public static, and it returns a string. Get, how about we just name it get window handle? And it return driver.getWindowHandle. We're finished with this method. The next method, public static string getWindowHandles with an S. Now, I made a mistake because I put public static string, but that's not correct. It should be set string, because it returns a set of window handles. Return driver.getWindowHandles, and we'll finish after I import set. You know what? Let's also include the other methods that I would normally include in this get utility class. I should have included them earlier in this course, but let's go ahead and do it now since I'm here. Public static string, and this method we have used throughout this course. Get text, pass in the by locator, import the by class. Now this return driver.findElement, pass in the locator, .get text. The next method is public static string get attribute. Pass in the by locator and also the attribute that's in the DOM. It returned driver.findElement locator .get attribute, and we pass in the attribute. Now we are finished with this get utility class for the getWindowHandles method, get text, and get attribute. This utility class, like I mentioned before, it is not required, just a way to organize our project and to quickly call a method that we may not want to add more information in other classes as time go on. Now, for the next step in this test, on the Windows page, we switch to the new window. The last two steps are to get the URL and verify the URL. So let's go back to the the get utility class. So we can get the URL by writing public static string get URL. And this here, we return a Selenium built-in method that's called driver.getCurrentURL. This getCurrentURL is built into Selenium to get the URL of the current browser. Now, back to the test. We write get URL. We call it and import the method. Now, the URL returns a string, and we will call it actual URL. Next is the expected URL, and we need to get that value from the application. Copy, and then come back and paste it. At this point, we need to assert if the URL is correct, that it equals actual URL expected URL with a customized message that says actual and expected URLs do not match. At this point, we can run and let's see if the test passed or failed. It should pass. Bingo, we see test new window URL, it passed. In the console, we see main window ID and number of open windows 2. Notice the main window ID and the first window ID has the same alphanumeric handle ID that ends with 6B78. That is because the main window and the first window is the same. You can handle a new tab the same way as a new window. That's it for switching to a new window. Next is dynamic wait statements. A dynamic wait statement is a statement that pauses execution for a certain length of time before moving to the next statement. We call it dynamic because it is flexible to wait for the specified time or wait for a condition. Here is a list of dynamic wait statements and a hard wait statement. The first method, thread.sleep, is a hard wait statement. It is not dynamic. An example of a hard wait statement is the delay method that was created in this project. It stops execution, but the test script stays asleep. That means execution will stop and not move to the next statement, even if the next statement is ready for execution. Selenium has more than one dynamic wait method. We see page load timeout, script timeout, implicit wait, explicit wait, and fluent wait. Page load timeout sets the wait time for a page to load. Script timeout sets the wait time for JavaScript to execute. Implicit wait determines the wait time to search for all elements connected to the driver. Explicit wait pauses execution until the time has expired or an expected condition is met. Fluent wait is a specialization of explicit wait. which also pauses until the time has expired or a condition is met. First up is Explicit Wait. Let's go to the application and let's see the dynamic properties on this page. We see the page has 2 buttons, but the third button shows up after 5 seconds. We need our test script to pause between statements because of dynamic content on this page. All 3 buttons are dynamic, but our test script will wait for this third button, then get the button name. Let's go to our project and create a utility class for dynamic wait. Expand main and Java, then right-click Utilities, New Java class. The name of the class is Wait Utility. It extends utility. Let's start by writing public static void. The method name is Explicit Wait. Selenium has a class called WebDriver Wait. The purpose of WebDriver Wait is to ignore instances of a not found exception until a condition has been met or time has been met. Next is the object reference wait. New WebDriver Wait. Now, WebDriver Wait can accept 2 arguments, the driver and duration. The purpose of duration is to poll the application up to a max of time we enter as an argument. We can add milliseconds, we can add minutes, we can also add seconds, whatever we choose. However, the button shows up after 5 seconds. So let's pick seconds, then pass in 5 and end with the semicolon. So far, this statement says WebDriver Wait will wait for an element up to a max of 5 seconds, or wait until an expected condition. Now, expected condition is also a class that has a lot of methods. The purpose of expected conditions is to allow our test script to wait until a condition is met. Our condition is visibility of element located. Now, this will wait for the element to show up when it's visible. It receives a by locator. Do you see the parameter at the top, by locator? So let's write pass in by locator. Now, let's also add some parameters. The parameters will be seconds, which is the integer, and the by locator. We must also import the by class. Yes. Also, go ahead and update the name to Explicit Wait until visible. Bingo. Now, we know that the 5 seconds is hard-coded, so let's change 5 to the parameter seconds. And now, this here is complete. When we call the method, we can pass in any number of seconds. This is how we create a dynamic Selenium explicit wait statement. For the AUT, we access this page by clicking the Dynamic Properties menu item within the Elements card. Let's inspect Dynamic Properties. And like other menu items, it has a parent tag that begins with LI and ID value, but this has item 8 as the value. What we need is the span tag that has dynamic properties. We find it by writing 2/li @id equal item-8. Yes, now we go to our span tag, which has a text value of dynamic properties. Now, we found it. Let me copy this value and go to the IDE. The page object, I believe, is elements page object. So let's find it by going to com demo qa.pages, the elements package, and the elements page object. Now, on this page, let's start with the field. The field name is private by, and let's name it dynamic properties menu item. We found it by XPath. Paste in the value. Next is the method, and that will be public dynamic properties page. The name of the method is click dynamic properties. First, let's scroll to the element using JavaScript, and I will import the static method. We'll scroll into dynamic properties menu item. Next is to click dynamic properties menu item. Last statement in this method is to return the new dynamic properties menu page object. Bingo. Now, let's go ahead and create the page object so we can get rid of this red writing. Right-click the elements package, new Java class, and paste in the value. Dynamic properties page extends the elements page. Yes. Okay, so now we have the page object. At this point, let's go ahead and start on the test. Go down to the test directory, right-click part 3/4 or expand part 3/4, expand the test directory, and we right-click part 4. New package. The name of this package, will it be dynamic? How about put dynamic wait as the name of the package? Right-click dynamic wait, new Java class. The name of this class is dynamic wait test, and it extends the base test from part 3/4. Okay, so at this point, we can go ahead and start writing our test, beginning with the test annotation to identify our test method. Public void test dynamic wait. No, well, let's name it test visible after button text, because we testing the name of the button when it shows up. Yes, test visible after button. We land on the dynamic page after accessing the home page and going to the elements card, and we click dynamic properties menu item. After clicking the dynamic properties menu item, the next step is to get the name of this button visible after 5 seconds. When we get the value, that will let us know the button has shown up on this page. Let's inspect it. And we see it has a button tag name with an ID value of visible after. Let me copy this ID value and make sure to find it. Yes, we found the element. Now that we found the element, let's go to the menu, the page object, dynamic properties page. And we will create the field and the method. The field is private by, let's name it visible after button. We found it by ID. Paste in the value. Yes, for the method, it is public string. The name is get visible after button text. The first step is to call that explicit wait statement. Let me import it. I could spell it out and import it after writing the method name, but let me just go here and just put import static. And we're importing from utilities, and the sub package is wait utility. And now we have it. So let's go ahead and write explicit wait, and it shows up. Now, at this point, we're going to pass in the parameters or the arguments. 5, name is visible after button. Step is to get the text, and let's get the text. So the next step is to get the text of the button, and we can call the get text method that we created in the last tutorial in the get utility class. And we do it by first returning get text, and we pass in the locator, which is visible after button. Import the get text method, and that's all we need, but I want to print the values. So let me go ahead and remove this return statement and assign it to string visible text. To print the value, let's write the print statement button text. The reason for doing this, I want to make sure that it print the text, and I want to see it in the console. This is not required, but I just want to see what it shows in the console. Visible text. At this point, let's go ahead and return the visible text, and that's it. Let's go ahead and continue with our test on the dynamic page. We are going to get the visible after button text. This will be a string with the reference of actual text. The string expected text is visible after 5 seconds. And make sure to put in a semicolon at the end. For the assertion, we're going to assert that it equals actual text and expected text. For the customized message, let's write actual and expected text do not match. You know what? Let's run. But before running this test, let me comment out the explicit wait statement so you can see what happens when it fails. Now, let's run. The console should return a no such element exception. It failed, and yes, we see no such element exception. Which one? That it could not locate. It could not locate visible after. Selenium executed so fast that it could not locate the button. That's why we need to instruct Selenium to wait for dynamic elements before executing the next statement. So now I will go back and remove the comment and run again. This time it should pass. Yes, it passed. And the console shows the button text. The name of the button visible after 5 seconds. That's it for explicit wait. Next is Fluent Wait. Fluent Wait allows us to define the number of seconds to wait for a condition, just like explicit wait. However, the difference between explicit and fluent is Fluent Wait provides more flexibility. It allows us to poll the application by checking the frequency of a condition and allows us to decide which exception to ignore. In the IDE, let's go to the WebDriver Wait class. And when I go to WebDriver Wait, we see it extends Fluent Wait. When I go to Fluent Wait, it implements wait. Now, let's go to our wait utility class and create a Fluent Wait method by writing public static void. The name will be Fluent Wait until visible. Then pass in 2 parameters, seconds and by locator. Now that we have this part of the method, we're going to call Fluent Wait with the reference of Fluent Wait. Then create an instance of Fluent Wait. After creating an instance, next is to pass in the driver. Now that we have passed in the driver, on the next line, write a dot operator, and we're going to call 3 methods. The IntelliSense shows us ignore all, it shows ignoring, it shows polling every, until with message is overloaded, and it also shows with timeout. The first method we will use is with timeout. With timeout allows us to provide the time unit by writing duration dot, and we see seconds, nanos, minutes, millis, hours, and days. We will choose seconds, then pass in seconds. Let me make more room. Okay, now that we have this part, on the next line, we're going to insert another dot operator. This time, we will poll the application with poll every. Duration dot. This time, let's use millis and pass in 500. 500 is the same as half a second. One more time, dot operator. This time, I will write ignoring. We determine which class to ignore. For example, in the previous tutorial with explicit wait, I commented out the explicit wait statement and the test failed with a no such element exception. With this ignoring method, we can decide to ignore the no such element exception. Now that we have ignored the no such element exception, we make sure to write dot class because it is a class. If you wanted to, you can add more than one exception to ignore. For example, separate with a comma. On the next line, let's write stale element reference exception and make sure to write dot class. Fluent Wait is flexible because of these 3 methods. With timeout, polling every, and ignoring is what makes Fluent Wait flexible. So on the next line, we're going to write the reference Fluent Wait dot until an expected condition. Even though it has conditions, we're going to wait for one condition, and let's use the same method that we use in the explicit wait statement, and that is visibility of elements located. Then pass in locator. After locator, make sure to complete it with the semicolon. And this completes the Fluent Wait statement. Next, let's walk through the test script. Then we're going to create the test script. From the home page, we will click Widgets. Then click the progress bar menu item. On this progress bar page, the next step is to click the Start button. Then wait for the progress to reach 100%. This time, our timeout must be more than 5 seconds, maybe 30 seconds. Let's go ahead and inspect the progress bar. And we see it has an ID value of item 4 for the parent tag. We need the child tag, which is the span element. So to find it, let's write 2/ li square brackets at ID. Then write the ID value, which is item -4. Yes, found the element. Now let's find the child element, which is span. Text and the name of the menu item, which is progress bar. Now we found the element. Copy the value and go to our page object. The page object is widgets page. On this widgets page object, let's provide the field, which is private by progress bar menu item. We found it by XPath. Paste in the value. Next is to write the method, which is public, and then the page object will be progress bar page. The name of this method is click progress bar. Now for the body, we first scroll to the element progress bar menu item, then click progress bar menu item. On this next line, we return to the progress bar page. We will create the progress bar page object by right-clicking widgets, which is the package, new, now Java class. At this point, paste in the page object name, progress bar page, and it extends the widgets page because that's the page that we landed on, which is widgets card. Now we have the progress bar page object created. At this point, we can write the first 2 steps of our test. Let's go to the same dynamic wait test class where we created and tested the explicit wait. And I'm going to write public void. The name of this test will be test, how about test progress bar. Notice one thing on this here class. I mentioned how we can add the test annotation from test.ng at the method level or class level. For explicit wait, it was added at the method level. And notice that it has a green arrow to run the test if we wanted to. But the test that we just created or will create, it has a method, but it do not have the green arrow. That's because it do not have the test annotation from test.ng. The moment I added the test annotation, we know it is a test method because it's identified by the test annotation. So if I remove the test annotation, the green arrow goes away. And the same for this method. But if I add it to the class level, every method in this class is identified as a test method. So now both methods has the green arrow to run. Either way is okay at the class level or method level. Now let's go ahead and continue with the progress bar. The first step is after it load the page, it will land on the progress bar page. And from the home page, the first step is to go to widgets. The second step is to click the progress bar. Those are the first two steps. The next step is to click the start button. Let me reload the application. Inspect the start button. And it has an ID value of start, stop button. Let's go ahead and find it to confirm we found it. Yes. So let's go back to the progress bar page object. And on the progress bar page object, we're going to start with the field. And that is private by start button. And we found it by ID. Let's paste in the value. Next, we're going to create the field, the method. And the method is public for the access modifier, void because it do not return anything. The method name is click start button. Called click, and we're going to pass in start button. Now we'll finish with the field and method on the progress bar page for clicking the start button. For the test, we can now write on the progress bar page, click the start button. Last step is to get the progress value. Let's go back to the AUT, and we're going to inspect the start button, the progress bar, before clicking the start button, because I want you to see something. Now, the progress bar, the parent, has an ID value of progress bar. Let me expand this, and on the next line, we see this area hyphen value now equals 0. I want you to watch this value after I click the start button. We see it's progressing, and the value is increasing, and it will increase the percentage until it reaches 100%. Bingo, now it stopped. This is the value or the element we need. Let's find it by starting with the parent tag. Div at ID equals progress bar. Bingo, we found the parent element. Now let's locate the child element by writing 1/ div area value now equals what value? 100. Bingo, we found the element we need. Now I copy the value and go back to the progress bar page object. And on this page object, let's go ahead and write the field, which is private by. The name is progress value by XPath. That's how we found the element. Now for the method, it will be public. And it also will be public string because we are returning a value. The name is get progress value. At this point, let me import the method we need, which is the Fluent Wait method. And import, and I'm going to call utilities dot wait utilities is a class, and I'm going to just write the asterisk. And for this, now let's write Fluent Wait until visible. And I'm going to import it. And I thought when I did, know what, I did not write static here. Okay, so let me go ahead and remove this import statement and use this Fluent Wait until visible method. And the number of seconds was the first parameter, and that would be 30. The locator will be progress value. We want to return the value. So let's call the getText method that we created in the getUtility class. Import the static method from getUtility, then pass in progress value. And that's it. Now that we have returned the progress value, let's continue with our test by writing progress bar, and on the progress bar page, we get the progress value. The return value is string, so we assign it to string with actual value as the variable. The string expected value is 100. And I'm not sure if it's 100 or 100%, but I'm going to put 100 and see what happens. Let's assert equals. And we're going to compare actual value and expected value with a customized message that says value is not 100%. And I believe this is 100%. But know what, just for now, let's go ahead and make it 100. And if it fails, we'll see how it must be detailed in what you write for the actual and expected result. Now, let's run. The dynamic Fluent Wait is causing our test script to pause for 30 seconds or until the progress value reaches 100. That's why it's dynamic and flexible. It reached 100 and it failed. Yes, it expects to percent, but at least we know that it waited. So let me go back and put the expected value as 100% with the percent sign and run again. This time it should pass. Yes, it's waiting for 30 seconds, which is the time, or until a condition reaches 100%. That's flexibility. And yes, it passed. Let me show you what happens if we do not allocate enough time. For example, go to progress value and change 30 to 5 and run again. When it reaches 5 seconds, it's going to fail because the condition was not reached within the time limit. If it failed and cut off before the progress bar reached 100. Now, the exception shows timeout exception. Expected condition failed. Waiting for visibility of element located by XPath. And it shows the value of the XPath. And it said tried for 5 seconds with 500 milliseconds interval. So I want to show you what happens if we do not allocate enough time before the value reached 100%. Let me go back and change it to 30. And that's it for Fluent Wait. Next is Implicit Wait. Most people implement their implicit wait statement when setting up their test. So in this base test, it would go in this setup method after driver.manage.window.maximize. And we write it starting with driver dot, then manage, followed by timeouts. This is where we use implicit wait, then pass in duration. And we can choose the time like seconds, then pass in 5. 5 seconds is what I see a lot of times as the default value. The process of implicit wait is to live for the life of the driver object. Therefore, it is applied every time our code uses the driver. As a result, each element implements implicit wait because the driver finds the element. However, we should never mix implicit wait with explicit wait or mix implicit wait with fluent wait. Combining implicit wait with another dynamic wait statement can cause unpredictable wait times. Let me comment out implicit wait. I saw that type of problem when I went to a project. The solution was to create a new framework because so many elements depended on the implicit wait statement. So when I removed implicit wait, there were a lot of failures because all of the elements that's found with the driver object, they start failing. So I had to create a new framework with page object model design pattern and only implement explicit wait and fluent wait. Now here is a quote from the official Selenium website. It says, warning, do not mix implicit and explicit waits. Doing so can cause unpredictable wait times. For example, setting an implicit wait of 10 seconds and explicit wait of 15 seconds can cause a timeout to occur after 20 seconds. So we should implement one or the other, and I prefer explicit wait. We apply dynamic statements on individual elements and not all elements. That's it for implicit wait. Next is page load timeout and script timeout. For page load timeout and script timeout, they are implemented the same way, and that's through the timeout interface. So in the IDE, let's go back to the base test. We can implement each one of them by writing driver.manage.timeouts. At this point, you will see both methods when I write time. Here's the page load timeout, and here's script timeout. For page load timeout, it allows us to enter a time for a page to load. If the page does not load, then we see a timeout exception in the console. For script timeout, it allows us to set the wait time for JavaScript. It lets our test script pause for asynchronous scripts to complete. Let me go ahead and remove this statement. That's it for dynamic wait statements, explicit wait, fluent wait, implicit wait, page load timeout, and script timeout. Next is Selenium interactions. Interactions is a package that allows us to simulate mouse movements and keyboard events. In that package, we can perform an action by using action without an S and actions with an S. There are times people confuse the two. In the IDE, let's go to external libraries. Scroll down to Selenium 4.23 or whatever version you have. When I expand org.openqa.selenium, that's when we see the interactions directory. Expand interaction directory, and that's when we see action without an S and actions with an S. The project shows action is an interface. It's an interface because we see I before action. The second one is a class because we see a C. If I open action, we see it only has one method, and that is perform. However, actions with an S has many methods. And it's a class with many methods that also include perform. Public void perform. In this tutorial, I will demonstrate how to simulate mouse movements and how to simulate keyboard events. Let's start with mouse movements. For our test script, let's go to the AUT, and the plan is to move this slider, get the updated value, then verify the value. The slider page is under widgets. We already have widgets as a page object. So let's inspect the slider menu item. It has a parent tag with an ID value of item 3. The child has a span tag with slider as the value. To find it, let's start with the parent. li add ID, put in the item -3 value, and we found the parent. Now, let's find the child by writing span, text, parenthesis, slider, and yes, we found the element. Now I will copy the value and go to the IDE. We must create a page object inside of, let's start with the widgets page object, and I'm going to create a field and a method in the page object for widgets. So we have that already. Main directory, Java, com, demo QA, and we see the widgets package and the widgets page object. Let me go ahead and remove or close the other tabs. And this here, we'll start with the field. The field name is private by. We could name it slider menu item. Found it by XPath. Paste in the value. Now let's the method. The method name will be public. Slider page is the page object that we will create. Click slider is the name of this method. First step, scroll to the slider menu item. Then click the slider menu item. Next, we return new slider page. Then we create the slider page object. Go to the project, and we're going to right-click widgets, new Java class, paste in the page object. Slider page extends widgets page. At this point, we have enough information to at least start our test. So let's go to the test directory, expand it, expand port 34, expand test package, and let's go ahead and create our information in a part 4 package, new package. The package name will be enter actions. Right click interactions, new Java class. And the name of the class will be slider test. And it extends base test from part 3.4. At this point, let's go ahead and start our test method by identifying the method with the test annotation, public access modifier, void. Name of the test is test slider result. Now, step 1 is from the home page, we go to widgets. Step 2, we click slider. After clicking slider, we assign it to slider page. Next step is to move the slider. So let's go back to the AUT and inspect slider. It does not have an ID attribute, but to find this element, let's use the type attribute, which has a value of range. The parent has an ID value of slider container, and the element tag name is div. So let's first start with the parent. 2 forward slashes div at ID equals slider container. Found the parent. Next is to find the child, which has an input tag name. Yes. So within the brackets, let's write at type, which is the attribute. The attribute value is range. Yes, so we found the elements we need. Copy the value, and I'm going back to the slider page object. In this page object, the field name is slider. Found it by XPath, paste in the value. The method is public void move slider. At this point, we implement the actions class with any reference, such as act. New actions. Also pass in the driver. Import actions. Now, next is to write the reference, which is act. We can call any method in the actions class. The IntelliSense shows us perform and many other methods. Scroll by amount, send keys. We see many methods. If I write key, we see key down and key up. Both are overloaded. Now, they simulate clicking the up and down arrow keys on the keyboard. If I write send keys, it's also overloaded. And that's send information. If I write move, we see move to element. That allows us to hover an element by moving the mouse to that element. Next, how about context? We see context click. That simulates clicking the right mouse button. If I write double, that simulates clicking the left mouse button 2 times because it's double clicked. Selenium also provides drag. We see drag and drop and drag and drop by. There is a difference. Drag and drop simulates the mouse by dragging from a source, then dropping to its target. Drag and drop by allows us to drag and drop an element using an offset. This project in this particular test will use drag and drop. With drag and drop, for the slider scenario, we need an offset for X and Y. First, we must find the slider. Then pass in X offset and Y offset. Both offsets are integers. So for the parameters, we're going to make those int data type. X, int, Y. And now we no longer see the red writing. There is one more method to complete the move slider process, and that is act.perform. The purpose of perform is to be a convenience method for performing all actions without calling build. Build is a method that collects a sequence of actions, then store all of those actions into one action. Right now, perform is on a separate line. However, the actions class allows us to chain the methods together. The same way we perform these here methods together. It's a chain. It includes more than one method within this one line of code. We go to widgets, then click slider. Well, for this here slider page, we can write this method for perform on the same line as drag and drop by writing the dot operator, then perform. So I can remove this line if I want to. Either way is okay, but that completes the slider process. Let's add this step to our test. So on the slider page, move slider, pass in X, pass in Y. Now we see red because we have not provided any values. Let's add those values at the top. How about I write for X, let's write int X equals 180. And for Y, let's make Y 0. X is horizontal. That means it moves left and right. Y is vertical. It moves up and down. So the next step is to verify the test. Let's go back to the AUT and inspect the slider value, because that's what we will get in our test. It has an ID value and a value, ID attribute and a value attribute. The DOM shows both, and we need both attributes. The ID attribute helps us locate the element. The value attribute is going to help us get the value. Let's find this element by writing hashtag slider value. Yes, we found it. Therefore, in the slider page object, we write private by slider value. We found it by ID and then pass in slider value. Now for the method, let's write public string get slider value. At this point, let's return get attribute. That's the static method that we added to the get utility class some tutorials ago. Now, for the get attributes, I must import from get utilities, then pass in the locator of slider value and the attribute. The attribute was value. The next step is to assign this value in the test after we first go to the slider page and get the slider value. Let's assign it to string actual value. Next is the string expected value. And let's say we expect the value to be 95. At this point, we can compare the two values, actual value, expected value. Then write a message that says something like actual and expected values do not match. Bingo. At this point, let's run. The test failed. Actual and expected values do not match. Expected 95, but actually show 85. That means that it should show up in a screenshot. Yes. Let's look at the screenshot to help us debug it. Even though we know what it says, we can look at the screenshot and it shows, yes, 85. So we can go ahead and run it again and change 95 to, change 95 to 85. You know what? To make this here tutorial course be like a real world project, let's add this actions information to a utility, because on a project, a good chance you would need actions again in some other tests and other class. So it's best to add it to utilities. Right click utilities, new Java class. Name it actions utility. And it extends utility. Let's start with the private method, because with that private method, it will only be used in this class. Actions is the return type. Act is the name of the method. We're going to return actions, and after returning actions, it must be new actions. Pass in driver. Then import actions. Yes, so now that we have this method for this class, because it's private, now we can add public access modifier, and it will be static void the name, drag and drop by. The parameters will start with WebElement, and that's the source. The offset, first one is X, second offset is Y. Also import WebElement. Yes. So now we can call this private method, which helps us to not write this here information over and over like we did in this slider page object. We don't have to do it over and over, the dry principle. So let's call act, and act provides access to drag and drop. Now we pass in source, X, and Y. And don't forget to write perform. If we do not write perform, the action will not perform. Now, let's call this method from the slider page object, and watch how much simpler it'll be. We only need to write drag and drop. Let's call a method, import the method. Now we pass in the same information we wrote right here. Find the slider, then pass in XY. And we don't have to write perform because the method we called it has performed. Of course, we can remove or comment the previous code. In a project, the code would not be here, but I'm going to comment it so you can compare and just walk through this video. Now, let's run, and the test should pass. Bingo, it passed. We see one run, one pass. That's it for simulating mouse movements using the actions class. Next, we're going to simulate the keyboard using the actions class. With the actions class, we can automate pressing keys on the keyboard. Let's go to the IDE. And in the IDE, we have this enum called keys, and keys implements char sequence. If I go to char sequence, the tab shows it is a Java file, and it's an interface. Char sequence is a Java interface that reads a sequence of characters. When it comes to the keys enum, it has many constants, starting with null. It also shows cancel, help, backspace, tab, return, enter. If I keep on scrolling, we see how we can press page up, page down with your keys on the keyboard. If I continue, we see the arrow keys. Also see where we can type numbers. Below numbers, it's a way for us to press the function keys. When it comes to our test script, we're going to enter full name, email, and current address. In addition to using the actions class, we will also use the WebElements interface. Both of them have the send keys method that allows us to implement the keys enum. For full name, let's enter something Rex Allen Jones II, which is my full name. For email, we're going to press the tab key, and we'll see how focus is now on email. After pressing the tab key, then our test will enter an email, rexallenjones@gmail.com. The last two steps includes typing current address and clicking the submit button. Current address will also use the keyboard when we type something like 1234 Selenium Avenue. Then press the enter key. Now focus is on the next line in this same current address WebElement. Type Suites 3400. Then press enter again. On the last line, we will type city and state, like Dallas, Texas. Then click the submit button. And we see how this here result shows the name, email, and current address. Our test is going to verify this information. Let's start by inspecting text box, which is the menu item under elements. Right click, inspect. When I make this bigger, the DOM shows it has an item -0 as an ID value in the li tag. That's the parent. The child is the span tag, which contains text box as the text. So to find it, let's start with the parent. li square brackets @id equals single quotes item -0. Yes, we found the parent. Now let's find the child with / and a tag name, which is span. Square brackets. Now the text is pasted and it shows text box. We have found the elements. At this point, let me copy, then go to our page object, elements page. And I'm going to start by creating a field. The field name is private by, private is the access modifier, by text box menu item. We found it by XPath. Paste in the value, then a semicolon. The method public text box page will be the page object. Click text box is the name of this method. First, let's scroll to the element. Which element? Text box menu. After scrolling, we're going to click text box menu item. Last statement in this method is to return new text box page. Yes, so now let's go ahead and create the page object for text box page by going to the project, right-clicking elements package, new Java class, and paste in the text box page. Text box page extends elements page. Now that it extends elements page, let me remove this import statement. Now that we have added the text box page object, let's write the first step in our test. But first, we must create the class, and the class will be inside of the interaction package. Part 3, expanded, test, part 4, interaction package. Right click, new, Java class. The name will be keyboard test, and keyboard test extends base test. Let me also make some room. Now, for the test, it begins with the test annotation because the test annotation identifies the test method. This name will be test application using keyboard. Yes. And the first step is from the home page, we go to elements, then click the text box. We assign it to the page, which is text box page. Yes, so now we have the first step. The next step is to enter the full name. Let's go to the AUT, inspect full name field, and it has an ID value of user name. Let's locate it to make sure it is unique. Hashtag, paste in the value, and yes, we see 1 of 1. Create the field with this value in the text box page object, starting with private by full name field, found it by ID. Paste in the value, add the semicolon. The method is public void set full name. And we're going to pass in the parameter a string name. The first step for full name is to scroll to the element using JavaScript. Which element? Full name field. Import the static method. Yes. The next step is to send keys. Now, send keys from the WebElement interface will work, but we're going to use send keys from the actions class. Therefore, let's write actions, then the reference act, new actions, and pass in driver. Let's import the actions class. Yes. Act is the reference. Send. Send keys is an overloaded method. One of them only accepts chart sequence, while the other one accepts WebElements and chart sequence. I mentioned earlier, chart sequence is a Java interface that reads a sequence of characters. WebElement is an interface that reads an element on a web page. That's the difference. Let's choose the one that's accepting the web element and the chart sequence. The web element is find. We must first find the element. Which element? Full name field. After finding the full name field, next is the chart sequence. And for chart sequence, we write keys. And when I add the dot operator, it provides access to those constants. If I cycle through these constants, we see delete, down, enter, and there are many constants, even the function keys. We're going to use chord as the key that we need. Chord helps send more than one key at the same time. It receives a chart sequence value. We're going to pass in name. And we must remember to always add perform at the end. Now that we have added the actions, you know what? Let me do like I did in the previous tutorial. I'm going to add actions to the actions utility. So this same information, we're going to call it from the actions class. So let's go to the actions utility and create a method to send keys. I'm going to start with public as the access modifier, and the return type was static, void as a return type. The name is send keys. Now, we saw a moment ago that we chose to send keys that accepted WebElements and the chart sequence. So that would be the same parameters in this method. WebElement, this name is source. Chart sequence, that's going to be the keys. Now we have that information. The next step is to call the private method, which is act. Yes, an act provides access to send keys. At this point, that's when I pass in the parameters. And the parameters is source and keys. And we must always write dot perform. Going back to the text box page object, let's call send keys. And at this point, we can copy the same information, find full name field, which is the element, and keys.chord, which is a chart sequence, and paste in that information. Import the static method. Now we are finished with the set full name, and it would have been much easier to do that at first. Coming out the previous two statements, well, let me go ahead and just remove that information. Now we are finished with the set full name field method. So let's go ahead and write our next step. The next step from the text box page is to set the full name. The full name, Rex Allen Jones II. Okay, so next is the email. When it comes to the email, it is not required to inspect and locate the field because our test will press the tab key after typing the full name. So in the page object, text box page, I'm going to start by writing only the method. There will be no field. Public, void, set, email, and passing email as the parameter. Now I'm going to call the set full name method in this class. Now I set full name. I'm going to write keys dot chord. At this point, our test is still in the full name field, but it is when we use keys dot, then we press tab into the email field. Into the email field, that's when we pass in email. And I must remove this outside closing parentheses and add it here. Okay, so now we have finished setting the email. Let's add this step in our test by going back to keyboard test. When I add this step, I'm gonna go ahead and run it so you can see the email and the full name field get entered into the application. Text box page, set email. What's the email? rexallenjones@gmail.com. And for information, that is my personal email if you want to contact me for questions, comments, or any kind of concerns. I'm going to place a breakpoint at lines 11 and 12 and then debug this here test. And let's see what happens. I want to debug so you can see the application show full name and email. And let's see. Okay, now we stopped at line 11, the first breakpoint to set the full name. Go to, and right now it's empty. It's nothing here. Go back to the IDE, and I'm going to step over. Now it should be entered in the AUT. Yes, it shows it shows the full name field. Set Rex Allen Jones II. I'm going to step over again, and this time it should set the email. Let me step into it, because we're at this part where it's going to tab from the full name field. Step over, and let's see what it shows us. Yes, it shows the email. So that is a sign that the tab is working for our test. Let me go ahead and just resume the program and finish the test. Bingo, we see that it's green and the console shows one pass. Okay, so that's how we do tabbing on a keyboard. Next, let's enter on the keyboard. Press the enter key. So we're going to inspect current address. And it has an ID value of current address. Find it by ID. And this time it is not unique. It shows 1 of 2. That means it's 2 values in this DOM that has the same ID value. I do not recommend using the ID Selenium locator because it's 2 elements that's same as this here. So for this scenario, I do not recommend the XPath with an asterisk as the tag name. For example, some people use this here, 2 forward slashes and an asterisk. The asterisk identifies any tag name. So if I continue with square brackets, @ ID equals 2 single quotes, and then I write the current address value and press enter, it still has 1 of 2. When I press enter, it will move from text area to another value in the DOM. It shows P as the element. So if we keep on going back and forth, it's going to navigate between those 2 elements. To make it detailed for what we need for text area, we remove the star or the asterisk and make it detailed with text area. Press enter. Now it shows 1 of 1. Let me copy that value. Then go to the IDE in the text box page object. And I'm going to write the field name, which is private by current address field. And I write by XPath, then paste in the value. For the method is going to set the current address by writing, let me minimize this, bring it up, public void set current address, and pass in address. We're going to find the current address field. After finding the current address field, we send keys. This send keys is from the WebElements interface. It also accepts chart sequence. For the current address field, first step is to type address. Then press the enter key. We press the enter key with plus keys dot, and it already defaults to enter. Select enter, and that is how we set the field with information, and then press enter. So it's going to allow us to enter the address, suite, city, and the state. Notice I did not call set from the base page, because normally I would write set current address field, then pass in the address. That's what I've done in previous tutorials. The reason why I did not call set and wrote complete find current address, send keys in this here, and I can also add plus after the address. I can do the same thing, but I did not call set because it first clears the information before sending keys to the field. And we do not want to clear the information before sending the keys, because if we write clear, it's going to clear the address before typing the suite. Then it's going to clear the suite before typing the city and state. That's why I called find send keys this here. And recall, find is also from the base page. So let's go back to the text box page and remove this set part. Okay, so now with the test, let's continue on the text box page. And I'm going to set the current address. What's the first line? The first line is 1234 Selenium Avenue. After this line, I'm going to start with the suite. And that's going to be suite 3400. Next is the city and state. And that's Dallas, Texas. Okay, so all the three lines should be displayed in the same current address box. Next is to click the submit button. Let's go on inspect submit. And it has an ID value of submit. Let's make sure it's unique by writing hashtag submit. Yes, it shows 1 of 1. That's what we need to create the field. Text box page, private by submit button. We found it by ID. Paste in the value. Now for the method, that's public void click submit button. Yes, next is to scroll to the element. After scrolling to the element, which is the submit button, we click the submit button. Yes, so now we are finished with the step for clicking the submit button. Going back to the test, the next step is to click the submit button from the text box page. We're finished with the automation part. Now let's verify how about we verify the suite in the current address? So that's going to be our focus. We could verify the name, email, and current address, but I would focus on verifying the suite in the current address, because verifying the name, email, and current address is the same as the previous tutorials when we get the information and compare it to make sure it matches. So to verify that current address, let's inspect current address, and we see the ID value that was the same when we inspected the current address field up here, because we see the ID value is the same. So if I come back here and I paste in, we see that's the one that showed 1 of 1, 1 of 2, and 2 of 2. So to make it detailed, let's write it using XPath with the P tag name by writing 2 forward slashes, P at ID equals 2 single quotes, and now it shows 1 of 1. Copy this value, go back to the page object, text box page, and I'm going to write the field, private by, and let's name it current address results. We found it by XPath. Paste in the value. Now we write the method and we want to get the current address, public string, because string is the return type. Current address, and we want to first wait using explicit waits until visible. And we're going to wait for 5 seconds, even though we know it's shorter than 5 seconds, but that's the max. Current address result is the locator. Import the static method. Then we're going to return get text, which is the method we created in the get utility class. We're going to pass in current address results, then import the static method. At this point, we are ready to complete our test, starting with returning from the text box page the get current address. Assign it to string actual address. Now let's assert that is true. Actual address contains suite 3400. Let's add a message. The message will be actual address does not contain suite 3400. Let's debug again, because I want you to be able to see the information in the current address, how all 3 lines show up. Okay, and know what? I meant to stop at the current address, but it's okay. Let me remove this and just walk through it. Set the full name, set the email, and now we're at current address. Go to the application and we see full name is here, email is here. Now it should set the address. Yes. Now it's going to skip a line in the same text area, set suite 3400 and Dallas, Texas. And we go to it and we see all 3 lines in the AUT. Next step is to click the submit button and then get the results. Click submit, get the actual address, and we see here it shows the address. Current address is what it received from the AUT. It also shows that it's true. So this here value assertion is true. That's how we know it's going to pass. Let me resume the program, and that's the information in the application, and it passed. So the test passed. We are finished with the course, Selenium using Java with TestNG and the page object model design pattern. Thanks for watching. Make sure to subscribe to this free code camp channel. Give a thumbs up to the video if you like it. Also, leave your comments, thoughts, and questions. I'll make sure to respond to your questions, any concerns you may have. I hope you have success automating the application and also testing the application. Thanks.